everyone, and welcome to this session on AWS for Beginners. AWS or Amazon Web Services is a cloud platform that provides a range of services for computing, storage, databases, and more. It's used by businesses worldwide to scale, innovate, and secure their infrastructure. AWS has a lot of key services that are really important to understand, such as EC2, which is essentially a virtual server that you can use to run your applications. Then there is S3, a crucial object storage system that allows you to store and serve large amounts of data. Lambda is another game changer. It's a serverless compute service that lets you run code without provisioning or managing servers. So these services are the building blocks of AWS, and understanding how they work together is essential to mastering the platform. And here's what we will cover in this session. First, we will introduce AWS and understand what it's all about. Next, we will dive into hands-on section with EC2, setting up your first virtual machine. And then we will cover AWS S3 and how to store and manage your data in the cloud. After that, we will talk about AWS IAM to secure your resources and control access. Finally, we will wrap things up with how you can kickstart your AWS career with certifications. But before we begin, please like, share and subscribe to Edureka's YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, check out Edureka's AWS Solution Architect Certification Training course. It is carefully crafted to meet industry standards and fully equips you with the AWS Certified Solution Architect Associate exam. With engaging and instructor-led live sessions, you will gain practical experience in designing, deploying, and monitoring secure and scalable applications on AWS. The course offers a deep dive into key AWS services such as IAM, VPC, EC2, and EBS, helping you build a strong foundation and advance your cloud career. So check out the course link in the description box below.
So guys, AWS, that is Amazon Web Services, is a subsidiary of Amazon.com and is the world leader in cloud computing market. Right? It was launched way back in 2006 when no company had the cloud computing business model. It took the risk, and now today 70% of the whole cloud computing market is residing on AWS. So now you can imagine how big AWS is, right? Talking about companies who are on AWS, let's look at some of the companies, some of the prominent companies who are using the AWS infrastructure. So these are some of the very popular companies like Kellogg's, Adobe, Airbnb, General Electric, Netflix and Amazon, which are using the AWS infrastructure for their operations. Now, Netflix and Amazon are completely dependent upon the AWS infrastructure. Now, you can imagine if these two companies, which are so big and the whole world is using it, even your application is going to share the same infrastructure as these apps. So you can imagine that your application is in safe hands, right? You can be assured with that. Having said that, let's move on to discuss, but why do companies use AWS? What's the advantage of having the cloud computing technology with you, right? So let's shed a light on that. And for that, let's take an example. Say you think of, starting a business, and say your business is Instagram. You think of launching the Instagram application and you have the application ready. So now you have to make it available to the world. So the first thing that you have to do is you have to invest some money, buy some servers and upload your application on it, and your application is up and ready, right? So you start with a small user base and you say, okay, so in 1 month or so, I can expect that so-and-so users will be there. But your plan doesn't go according to your will. And what happens is overnight, your application becomes so viral that there are millions of users who are trying to access your application now. So the servers that you had are now very overburdened with the kind of traffic which is coming in. And you get very anxious as to what to do. So what you do, you invest some more money, buy some more servers, and now the situation seems to be a little normal, right? But guys, servers are machines. We should not forget about it, right? And they are bound to break down. So one fine day, what happens is your servers, they go down, they go haywire, and your application is not working anymore. So to fix this, again, you had to hire a maintenance team, which is now going to manage your servers for you. That is, any kind of server upgrade which is required, any kind of software patch which has to be put in, or when your server goes down, replacing it with a new server, all of that is now going to be managed by the maintenance team, right? So the kind of attention that was required for you to give to your application, it could not get that attention because half of your attention was towards the infrastructure side, which is understandable, right? So these were the problems before cloud computing. And one fine day, AWS came up and said, but why don't you use my servers, right? I have a stack of servers in my warehouse. Why don't you use some of them, right? And the best thing about it is that, you don't have to buy the servers from me. You can just rent them from me, use them for the time you want it to, and give them anytime you want. Say you gave it to me after 5 hours, you just pay for the 5 hours time that you used it for, right? At the same time, you don't have to worry about the maintenance, right? I will do the maintenance for my servers. And with this was like, the God came in and said, let me help you out. It was like that. So this was a very good deal for you because now you're not spending money on buying servers. You're not spending money on the maintenance team. Everything is being managed by AWS and at a very cheap price of per hourly basis, right? So it's very awesome. So moving forward, we've understood why, AWS companies are adopting AWS or any other cloud platform and what exactly is AWS, right? Let's move on to discuss the services now. So let's take an example again here. Let's take the example of a website. So this is a skeleton architecture for a very normal website that is there, right? How does it function? The user first, he goes onto a website, he goes onto the internet and he types in a web address, right? That web address then goes to a DNS server. That DNS server basically gets that converted into an IP address. That IP address points to a load balancer. That load balancer in turn is distributing the traffic among many of the servers, and you end up on any one of these servers. This is how it happens, right? And now this server is again connected to a relational database, and this relational database is basically having all the information which is required for your website. And also both these entities, that is your database and your servers, are inside a network so that they can communicate with each other, right? So these are the basic entities which are there in a cloud computing world, right? Now taking the same problem as before, that suddenly a whole lot of user group comes in and your servers become overburdened. Now how do you take care of that? So you don't have to take care of anything. Cloud computing, the cloud computing model is such that it will take care of itself, right? So it automatically senses that the servers are getting overburdened. It adds a server automatically, and now your situation becomes normal, right? So this is how the cloud computing world is going to help you out. We discussed this already, right? But now, having seen this architecture, how it works, now let's look at how these services or how these components will look when we look at from the AWS perspective, right? So when you talk about AWS services, the DNS server that we discussed is called Route 53. The servers, the web servers that we discussed are EC2 servers. The relational database is RDS. The network in which these components will be enclosed in is VPC. And the load balancer is again load balancer. And the property which increases the number of servers and lowers them according to traffic is auto scaling, right? So these are some of the basic services offered by AWS, and these are awesome, guys, right? So these were the services that we were to discuss. Moving forward, now let's discuss about the global infrastructure that AWS has to offer. Now, AWS provides these many services throughout the globe. It has a global presence, right? And these orange dots are the regions that AWS has, right? Each region has multiple zones, and zones are nothing but huge data centers with a lot of servers, right? So probably when you choose America, when you choose the US, so probably you'll be ending somewhere around here, right? If you choose a region, one region is this and the other region is this. One zone would be one circle, and this is how it functions, right? So in all, there are 18 geographical regions around the world, and in those regions, we have around 50 availability zones, right? So there are 50 huge data centers around the world that are at your disposal, right? But why will you need a global infrastructure is a question, right? So say we take the same example forward, the website servers, and these servers are now distributed among different places throughout the world. Now, what advantage does it give you? First of all, it helps you in a disaster recovery kind of situation. For example, this server goes down, you all again have these two servers to serve your traffic fraud, right? So this server goes down because of power outage or any natural calamity, your application is still up because it has been hosted in different regions, right? This is one advantage. The second advantage is that it serves the purpose of users from different countries. For example, you are in this country and you're trying to access your website, probably you can access it from this server, right? Rather than having your servers at one central location, which will not only have more latency, that is response time, if a customer is out of the country, but also it's a very bad measure to take when we are to consider about disaster recovery, right? So this is the reason that AWS has a global presence, that they have a global infrastructure. So it is there because so that your customers can have the lowest latency possible, and also you can implement the best disaster recovery measures. All right. Having said that, let's now talk about AWS pricing, guys. Now, AWS pricing is amazing, So, like we discussed, so we have a per hour billing kind of system, right? So, and the pricing is also region specific in the sense that each region has different pricing for different services. They don't differ much, but still they are different from each other for each region. So you can choose a region according to your preference. Also, there's a scene called reserved instances. So when you choose reserved instances, you save up to 90% costs. So when you say reserved instance, it basically means you rent the server for a particular term, say a 1 year term or a 3 year term. And when you do that, when you compare it with on-demand pricing, you save up to 90%, which is awesome, right? And also there is an option for spot pricing as well, wherein you get incredibly low prices by bidding on servers for a particular price, right? So you bid on server for, say, I want a server for $2. If a server is available, you get it, right? You use that server until the server price goes up. And once it goes up, the server is taken automatically for you, right? It could be helpful for workloads wherein the work is not that urgent, but you want to get it done in the minimum cost possible, right? So it is helpful in that.
Now that we know what AWS is, let's jump into something more hands-on. We are going to create our first EC2 instance. So let's get started.
So EC2 is a service that provides scalable virtual servers in the cloud, and these virtual servers in the AWS environment are referred to as instances, and they can be made up of different instance types and sizes. So by instance type and sizes, I mean that it describes the hardware component that an EC2 instance would run on. So this would include your number of processes, amount of memory, network performance, and so on. And within EC2, the service is highly scalable and you can opt in for pay as you go model. So in the later part of the session, we'll talk about various purchasing options that are available within EC2. So the most commonly used one is pay as you go. And there are other options available wherein you get significant discounts if you put in a commitment for a time duration and you're willing to pay some upfront cost. The full form of EC2 is Elastic Compute Cloud. So coming back to various instance types, so as I said, we specify the various hardware components that your instance would run on, and that would include your processors, memory, network performance. So as a solution architect, it's very important to use the proper instance type to handle your application's workload. There's a predefined collection of instance types that are grouped into families and types that you can choose from. And very shortly, we'll see that in the demo. So a couple of benefits of EC2. I'd been performing demos wherein I was able to spin up a virtual instance in under 2 minutes. So it's pretty easy, flexible, it is scalable. So in isolation, the scalability is not achieved. So I believe in the next session, when I talk about auto scaling, that is part of the EC2 services, you can achieve the scalability aspect wherein you can automate the entire process. Let's say you have defined a threshold that if the traffic exceeds X percentage or CPU utilization exceeds X percentage, you can spin up more number of resources. Service is fully reliable in the sense, if you do it right, if you configure it right, you will see known downtime. So recall, we have this first session, we had said that your workloads should be distributed across multiple availability zones. So define health checks. Even if an instance goes down, a new instance can come up on the fly and you can set it up in the operational state. With respect to security, there are tools and methods available in form of security groups so that you can filter both incoming and outgoing traffic. And it is inexpensive, so you go by an hourly rate. So that way, if you want to do a test for a couple of days, just pin up the instances for a couple of days, and that's about it. And you only end up paying for that period. So in the context of EC2, the first term that we need to be aware of is AMIs. AMIs stand for Amazon Machine Images. So Amazon Machine Image is actually a template that is required to launch a EC2 instance. And the template includes the information such as operating system, any application software packages on top of that particular operating system. So that's the prerequisite. The first step of provisioning your instance is to either pick up an AMI that is available with Amazon, or you can create your own AMIs. So I've logged into the AWS console and we'll go to the EC2 dashboard. So EC2, first of all, is a region specific service. So make sure you are in the right region in which you want to provision your virtual servers. And as I said, you can pick up AMIs either from Amazon. So there are multiple options out here. So during the launch process, as a first part of the process, you'll have to select an AMI. So there's a quick start section, which includes the most commonly used AMIs. So you have Amazon Linux distribution, and it would give you the details, what are the application packages on top of this operating system. So for most part of it, we'll be using Amazon Linux AMI. And in this case, it has Python, Ruby, Perl, and Java already pre-baked into this template. So likewise, there are a set of AMIs that are available, and please note that only pick up the AMIs that are eligible for free tier. Then you have My AMI section. So these are the custom AMIs that you can build. So either you can build your own AMIs, pick it up from the quick start section. And additionally, there are a lot of options available in the AWS Marketplace. So it is very similar to your Play Store and App Store, wherein you get a lot of options available. So for example, you are looking for an endpoint protection software. So you already have a pre-baked AMI for it. So over and above the cost of the EC2 instance, usage of this AMI would cost you like 1 cent per host per hour. So there are good number of options available. So let's say you want to find Tableau, which is a BI tool. So you have most of the options available out here. So in a rare case, you don't find a software appliance in the quick start or in the marketplace. So what you can do is you can purchase the license on your own and use that license on top of your EC2 instance. So using this template in one go, you can actually launch as many number of instances that you may want to launch. So every account comes with a soft limit, wherein Amazon would simply not allow you to launch 100 instances at a given point of time. That's simply because to prevent accidental misuse. So there are soft limits on your account, and I'll come to soft limits again once we get into the demo part. With respect to security, we have security groups that operate at the compute layer or at your instance level. So security groups, they act as a virtual firewall that control what traffic, both incoming and outgoing traffic. So in this case, all what you need to do is you need to specify within the security group that for which protocol, which port number, what is the source and what is the destination that you want allow the traffic to be allowed. So in security groups, you can only specify allow only rules. And instances within the same security group, it depends on the configuration whether you want them to communicate or not. So it's up to us. And these security groups internally, they are applied to the network interface of your compute resources, because your network interfaces form both entry and exit point for your compute resource. So the process to create a security group is very straightforward. So let's see that in action. So I can create a security group during the instance launch process, or I can create it beforehand. So the option is purely with us. So let's say I want to create a security group for my instances in the web tier. So I'll give it an appropriate name, WebSG. I'll have to specify the rules. So I'll have to specify the type. So in this case, let's say I want to allow SSH access to my instance. So SSH works on port 22. I have to specify the source address from which I want to allow this SSH connection. So you have custom anywhere my IP. So for demo purposes, I'm saying anywhere, but in real-time scenarios, you make sure that you make it custom. And the second rule that I'm adding, since the security group would be applied to your instances in the web tier, so I'll be allowing HTTP traffic as well. So the rules that I just set up in this security group, these are inbound rules, and by default, all the outbound traffic is allowed. So we can change that, but this is the default behavior. So in this context, outbound would mean any traffic generated from within the instance to outside that instance. So now it could be to another instance, it would be to an internet resource. So it is a resource outside that instance. So the illustration that what we have out here, this is you see a firewall out here wherein that controls the traffic. So a good example, I can give you a better architectural representation with respect to security groups. So this is a three-tier architectural representation. You have web, app, and database tier. And this tier is associated with one security group. This tier is associated with another security group. And my database is again associated with third security group. So in this security group, I'm controlling the traffic that is coming from outside. Likewise, for app server, I can control the incoming traffic only from the web servers. And likewise with the database servers, I can control the traffic only generated from app servers. So one of best practices is include security at every layer of your application. So at the compute layer, you should be using security groups to control both inbound and outbound traffic. And lastly, security groups are stateful. So stateful in this context means that any traffic that is allowed in the inbound rule, the return traffic would be allowed by default. So regardless of whatever the outbound rule says. So we'll see that in action very shortly. So there are other representations as well. This could be considered as a web or rather web tier, and they are spread across multiple availability zones and they are part of the same security group. At the network layer, again, you can have access control lists that would further filter the traffic to your compute resources. So in the illustration that what we see on the screen, again, we have a three-tier architecture. So web tier, this could mean X number of my virtual servers or instances, and application tier again can have X number of instances, and likewise for database. So we are opening for web tier, we have opened ATN 443 if you have configured SSL. For application tier, again, you'll open up connections from web tier. And additionally, you might want to open SSH connection for you to access the instance directly. The next term that we should be familiar with is key pairs. So EC2 key pairs, they are cryptographic secure keys that are used by AWS to authenticate a client when logging into a EC2 instance. So it's a combination of public and private key, and collectively they are referred to as a key pair. AWS stores the public key on the instance and the end user gets to download the private key. So to log on to an instance, let's say if we are using Linux instances, so by default, they have no password. We only use the key pair to log into Linux instance. And for Windows distribution, you use a key pair to obtain admin password and then log into the Windows instance using RDP. So during the creation of EC2 instance or otherwise as well, you are required to create a new key pair or use an existing key pair that can be tied to the instance. So the idea here is to provide a secure mechanism to connect to your instance. So let's go back to the EC2 dashboard, and just below security groups, you have key pairs. So you can import a key pair or you can create a key pair on the console directly. So I'll create a key pair, and so now AWS would generate a public key and a private key. In fact, it has already started downloading the private key pair. When we provision our instance, we'll have to associate a key pair with the instance, and AWS would associate the public key with that instance, and I'll be using this private key SSH into that instance. So I've got this key, so I'll just save this key. So now we'll proceed with the demo on provisioning our instance. So this time we'll take it slow, understand various attributes associated during the provisioning of the instance. So make sure you are in the right region, go to launch instances. The first step is to select the right AMI that you want to provision. And for the first part of the demo, I'll be using Amazon Linux AMI, and it is marked as free tier eligible. Next, you need to choose an instance type. So instance type, as I mentioned earlier, it refers to the hardware specification in terms of number of CPUs, memory, storage, and network performance. So there are multiple families available. You have general purpose, then you have compute optimized. So general purpose offers you a right blend of compute and memory. Compute optimized, as the name suggests, would give you more compute power as compared to memory. Then you have memory optimized, GPU for if you have media workloads to operate with, memory optimized. Then you have storage optimized as well. So you have good number of instance types available, and you can always, let's say you picked up a wrong instance type and you want to either scale up or scale down, meaning you want a better configuration or probably a lower configuration. So doing that is always a couple of clicks away. So you don't need to remember these configurations per se, but have a generic idea that what are the various families available. So as the name suggests, for compute optimized, it would offer you better compute power as compared to other parameters. General gives you the right blend. So if you really don't, you're stuck, what should I choose? Go ahead and start with general. So make sure you select the one which is marked as free tier eligible, because that should serve the purpose for us. The next step is to configure instance details. So this is where you set up all the configuration parameters. So the first part is number of instances. So I can specify, let's say 10 instances out here. So it will use the same configuration to provision 10 resources for 10 instances or virtual servers for us in one go. Recall a while back I said that there are software limits on your account that are imposed by AWS. So that's simply because to prevent accidental misuse. So as a solution architect, let's say you're planning to do a rollout. So make sure that you check on these soft limits that are applicable to your account. So as it stands today, the limit on my account is 20. So when I had signed up, initial limit was probably 1 or 2. So since this is a soft limit, all what you have to do is just create a ticket with Amazon, specify why do you need additional resources, and they kind of do it on the fly. So you can put in a ticket, right? You have a link request limit increase. So EBS falls under EC2. So this is where you would see EBS network limits as well. So the maximum number in my case that I can put here is 20, but we'll start off with one instance, the network parameter and the subnet parameter. I'll be talking in detail in the network section, wherein the network service allows us to build our own private virtual cloud. So at this point of time, we are using default network, which again is dedicated to my account. So earlier what used to happen was when you sign up for the account, it was up to the customer whether you want to create a VPC or not. But for security reasons, over last several years, Amazon by default would create network environment for you, and that is like your private space in AWS. So it is up to us whether we want to use the private network built by Amazon or whether we want to build our own. So 9 times out of 10, if you talk to your network teams, you will be building your own environment. And likewise for subnets. So subnets in this context refers to the availability zone that you want to use to provision your instance. You have a option here, assign public IP address. So by default, it is enabled. So for me to connect to this instance that would be provisioned, so how do I connect to it? So this machine needs to be associated with a public IP address. So I leave it as default. So I'll come back to these options in the second part of the demo, rest part of the. Next part is to add storage to this instance. This is elastic block storage, commonly referred to as EBS storage, that we are attaching to this instance, and this is a network storage. So this volume type is being referred to as a root volume. So root volumes are the ones on which you install your operating system and other application packages. So to start off with, we are attaching 8 gigs of volume to the instance that we are provisioning. Next, tags. Tags play a very important role, so help you identify resources. So you can add multiple tags. So let's say project ABC, you can add cost center. So whatever code, you could filter out the information based on tags, so to capture a lot of information. So let's say I want to capture what are resources being consumed by project ABC, I can do that. What is the total cost being incurred by resources in this project? So you can do that. So tagging plays a very important role. Next step is to configure security groups. So you could have created the security group at this point of time. The process is the same, or you can select an existing security group. So we had created a security group a while back. I'm adding the rules again. I'm creating a new one right now. And it gives you a warning message that you're allowing sources so anybody can connect. The last step, review your configuration, what we have said in previous screens, and launch. So when we launch our instance, it would prompt us to choose an existing key pair, create a new key pair, or proceed without a key pair. So depending upon the level of automation that you have implemented, I've seen some organizations, they actually don't allow SSH access to instances at all. So they don't create a key pair. So both the options are available. In our case, we'll choose the key pair that we just created. That's about it. So the current state is pending. All the attributes that you see in the description tab, these are essentially configuration parameters that we supplied during the process. So it has picked up availability zone 2B. So we let Amazon pick up the availability zone for us. It has assigned a public IP address. So I'll be using this to connect to this particular instance. Lastly, the internal private IP address that has been assigned is the one that we see on the screen. Next, in terms of connecting to this instance, so if you have a SSH client or using a Mac terminal, you can directly do a SSH with the key that we downloaded from Amazon. Else, if you are using a Windows terminal that does not come with a default SSH client, I'm using PuTTY to connect. However, PuTTY does not recognize the file format that we downloaded. So we'll have to change the file format. So this is an optional step only for Windows users. So you download PuTTY, and there's another tool called PuTTyGen that you can use to convert the format. So I'm using PuTTyGen to convert the format. So please note this is an optional step only for Windows user trying to connect to your instance using PuTTY. So I use the tool to convert the format, and now we are good to go. So I'll be using PuTTY. So I'll just grab the public IP address of this instance. I'll have to pass the path of the private key file for authentication. So for Linux distributions, you don't need to supply a password, and the default username that we use to log into the instance is EC2-user. So I've been able to log into this instance, and I'll just upgrade my privileges. So what I'll do now is install web services. So now these commands are operating system specific. So depending upon your comfort level with any operating system, you can try this out. And if I try to access at this point of time, so since the web services are not running, I don't get anything. So this is the default page. So let's go ahead and change this default page as well. So we are good here. So we have seen how easy it is and the flexibility that the service gives us to provision instance within a couple of minutes. So now in this case, I actually had to log into my instance to perform certain steps, but there are ways to automate to get your instance into the desired state. So in the next part of the demo, we'll again launch a EC2 instance and we'll try to automate the process. So before we get there, let's check other options available at the instance that we just spin up. You have status checks. So two types of status checks. One is system status and instance status. So make sure that these two checks have passed before you actually start using the instance. Then with respect to this instance, you will see metrics like CPU utilization, disk read, networking, all the metrics that are associated with this particular instance. So the details that are available under the monitoring tab, they are actually coming in from the monitoring service, which is CloudWatch. And lastly, you have tags. So the tags that what we see here is what we set up. So I can add additional tags anytime. So I'm provisioning a second instance. I selected the AMI, and again, the family is general purpose. So in the third part of the step, so let's take a look at other options that are available. You have shutdown behavior. So an instance can actually be in multiple states. It could be in running. That means it's operational. You could stop it. So that means you are releasing the hardware capacity back to Amazon. So in that case, you will not be charged for the compute resource. But please keep in mind that you will still be charged for the storage component. So recall in the previous demo, we had attached 8 gigs of storage. So I'll not be charged for my compute resource, but I'll still be charged for the storage component. So a lot of organizations actually what they do is during their working hours, they'll start the instances and off hours, they stop the instances to save on cost. You can actually automate this entire process. And then the state is terminate, which means that you're releasing the capacities to Amazon forever. So you'll not get the same system state back. So you're releasing the capacity. So in termination, you have an option whether you want to terminate the storage component as well or not. Then you have an option of enable termination protection. So in this case, if you enable it, the users would not be able to terminate the instance. This is simply a preventive measure so as to prevent accidental termination of your resource. Then you have monitoring, which refers to CloudWatch service. So by default, CloudWatch offers two flavors. So one is basic monitoring, in which the metrics are captured at a 5-minute interval. And there is detailed or enhanced monitoring, which is a paid version where the metrics are captured at a 1-minute interval. So detailed monitoring is chargeable, whereas basic monitoring is free of cost. So for production environments, if you want to use CloudWatch, make sure you enable this. Tenancy attribute, I'll discuss it in a bit. Now we're trying to automate the process to get the instance into the desired operational state. So in this case, I'm just repeating the steps that I performed after logging into the instance. So I'm passing this as a user data. So once the instance is in running state, it would execute these commands and get my instance to the required operational state. Next part again is adding the storage to this instance, and you have an option of delete on termination. So this is where you can decouple your storage component with your compute resource. So if I uncheck that, so when I issue a terminate command, only my hardware resources would be released. My storage component would still be available to us. So I can use that with another instance or for any other purpose. So I'll be using the same security group that we created earlier, since this is again part of the web tier. I'll associate the same key that we created a while back. Various attributes associated with the second instance that we have provisioned, but as associated with a public IP address, likewise it has a DNS name. So we can either use the DNS name or the IP address directly. So now for the second instance, I actually did not have to log on since I had bootstrapped the instance. And we are assuming that this state is the operational state for this instance. So there are multiple ways of approaching to this, wherein do it yourself, wherein you provision an instance, log in, get it to a desired state, automate the process. Bootstrapping is the first step in doing so. And as we move ahead, we'll be talking of various other tools like Beanstalk, Opswork, CloudFormation that further help you manage resources as a group of resources. So the next step is creating your own custom AMIs. So let's say the instance that we just created is the one that we really want. That serves as a baseline for us for provisioning further instances. So we can go ahead and create custom AMIs. So go to images and create an image. So on the left hand side of the pane, you have under images, you have AMIs. So this would indicate all the custom AMIs that you would have. So it actually depends on the size of your instance, and it's relative to time it takes to create the image of it. Okay, till the image comes up, with respect to storage, we can take a look at volumes. So we have two instances available to us and we're using two volumes. These are indicated in the volumes tab and the state indicates they are in use. So now the status is available. That means the AMI has been created. So now if I was to provision an instance, I can use this AMI as my baseline to provision it. So rest part of the process is pretty much the same, wherein you select the instance and various other configuration parameters. So this is my baseline instance. So meanwhile, I'll go ahead and terminate the instance. So this is the instance that we just provisioned. So again, we have this instance ready in the desired operational state. So custom AMIs is one of the methods that you can use to set up baseline image for your specific component of your application, and could be used as backup method also. So in case something was to happen to my compute resource, I can use this AMI again to provision a new instance. So we have already seen that the provisioning of instance happens like under 2 to 3 minutes. So this is good for environments with less dynamic release cycles, wherein I've seen organizations doing multiple deployments as of today. So maintaining AMIs in those cases would be an admin nightmare. So depending upon your specific use case, if the release cycle is less dynamic, you can use the AMI approach, or else we can use different other tools or build in automation to mitigate the effect of the an outage. So I'll just quickly connect to one of the instances. Let's connect to Web 2. So what I'm trying to demonstrate here now is user metadata and instance metadata. So in the first part, we'll be looking at user metadata. So this is essentially the script that we supplied during the boot process. So that would be visible to us. So this is the user metadata, essentially the configuration or the script file that we supplied during the boot process. The second one is the instance metadata. So this is information about the instance itself. So the attributes that what we see in the description tab, if I want to check these attributes at the instance level, I can refer them using instance metadata. So these are static URLs. So 169.254, 169.254. This is a loopback address that is assigned to every instance. So this would always remain the same. So if you had to check the user data or instance metadata, you'll be using this. In this case, you see all the attributes that are available at the instance level. So for example, you want to check from your instance, what is the public IP address available or assigned to this instance, you'll get to know that. So if you want to check the details about instance attributes, you'll look out for instance metadata. And if you want to check the script or series of commands supplied during the launch process, you will look out for user metadata. So I have given you both these URLs. So these URLs would be applicable across all the instances. So the next thing that what we'll do is we'll analyze the stop behavior of when we stop the instance and start it again. So I've captured the public IP address that has been assigned to this instance. Now, if I were to actually stop this instance, that means I'm releasing my hardware resources back to Amazon. So in this case, what has happened is the private IP address remains the same, but the public IP address that was associated with this instance, you lose the affinity to it. So if you stop an instance and start it again, your instance would lose the affinity to the public IP address that it was assigned to it earlier, and the instance would get a new public IP address assigned to it. So this is something that is controlled by Amazon by default. And there are ways and methods. Let's say you want a static public IP address. So there's a way to do it. And that I'll be demonstrating in one of the demos today itself. So if I start it, so this time the public IP address that has been assigned should be different. So this is a different address than the one that was assigned earlier. So directly or indirectly, you will be tested on this behavior, that what would happen if you stop the instance and start it again. So public affinity to the public IP address changes. So we've seen the demo of creating a custom AMI. And in the next part, what we can do is we can provision a Windows instance. So I'm picking up a lightweight Windows instance, which is 2012 base edition. So rest of the steps are pretty similar. So we'll pick up an instance type, configure instance details. So we'll keep it as same. Then add storage to this instance, apply the security group. So in this case, let's say app security group. Since this is a Windows terminal, we'll be using RDP to connect, and that works on 3389 launch, and then associate this instance with a key pair. So we'll use the same key pair that we created a while back. So the instance is running, and in this case, we'll be using the private key file to generate the admin password for us. So the way to do it is go to connect, select the instance, go to connect, and then get password. So typically it takes about 2 minutes or 3 minutes for the service to generate the admin password for you. Just specify the key pair path and decrypt password. So this is the password that it has generated. So to connect to this instance, I'll be using the default Windows client. So you now have access to a Windows terminal, and you can perform any actions if you want to use Windows IaaS on top of it, any specific middleware applications that you may want to use. So the process of you need to have a baseline understanding of Windows on how to perform those steps. So we have seen 3 or 4 demos on provisioning Linux and Windows instances. So essentially the process is the same. The method of connecting to each distribution is a bit different. Otherwise, at the OS level, you need to have, or the guys working for you need to have an understanding on working on that operating system. So one thing on security groups before we move on. Okay, so this is working. So earlier, to control inbound traffic, we had said we are allowing access on port 80 and port 22. So let's say I was to X out both, or rather HTTP access to this. So now if I was to access it, this should not be available. So this means any changes that we apply to the security group, they are applied on an immediate basis. So you can expect a scenario-based question that we make changes to the security group and what is the overall impact. So the changes are immediate in nature. Another thing that we said was that security groups are stateful, which means that if you have allowed traffic in the inbound traffic, the return traffic would be allowed by default, regardless of what the outbound rule says. So let me see if I'm connected to the right instance. So now if I want to access traffic outside this instance, so let's say, so I'm able to access. So this refers to the outbound traffic. So if we take a look at the outbound traffic, all traffic is allowed by default. So you can actually change that. And it's always a very good idea that you do not allow any traffic generated from that instance to go outside. So what I'll do here is I'll just simply go ahead and kill this rule. So now I am not able to access any resource outside the instance, but I was still able to SSH into this instance. That's simply because in the inbound rules, I've specified SSH access is allowed. So this is where the term stateful comes into play, that if you have set up an allow rule in the inbound rules, the return traffic would always be allowed regardless of whatever you say in the outbound traffic. So right now, no outbound traffic is permitted. And even if I try to access the web page, I'll still be able to. So this is always a very, very good practice. Even if a hacker was to get into your compute resource, since you have already set up that no traffic generated from that instance is allowed outside, you are looking at a good security option for your compute resources. So moving on, we'll talk about hardware tenancy. So when we provision an instance, we have an option to choose the tenancy. So what does tenancy mean? So tenancy in this case means that whether you're willing to work on a shared tenancy or a dedicated instance tenancy or dedicated host tenancy. So let's say I pick up this AMI. So you have a tenancy attribute out here. So the first one and the default tenancy that is selected is shared tenancy. And how this works is in the background, you would have a physical host. This physical host in the shared tenancy model would be shared across multiple AWS customers. So let's say I have provisioned 2 instances. There could be another AWS customer who could be assigned this physical host. So this is the shared tenancy wherein the underlying physical host is shared across multiple AWS customers. So this is the cheapest options of all. And for lower environments, it's a great fit. Also recall that when we talked about the stopped behavior of when you stop an instance, it loses the affinity to the public IP address. So there'll be thousands of physical hosts with Amazon. So let's say if I was to stop this instance, I'm releasing this capacity from this physical host. So this is gone. So when I start it again, it is likely to be provisioned onto a different physical host. So in the background, it loses the affinity to the physical host. So I'll come back to this reference when we start talking on EBS because there's an option that you can use out in the shared tenancy attribute. Then you have dedicated host. So in this case, what would happen is Amazon would allocate dedicated physical host to your account, and you have a dedicated physical server to your account, and you are responsible for provisioning your instances on top of that physical host. So in this case, in the case of dedicated host affinity, your affinity between the host and instance is always maintained. And you additionally get visibility to various other parameters such as number of sockets, cores, and host ID. So specifically, if you want segregation at compute layer, you can opt in for dedicated host model wherein you would be assigned dedicated physical host, and any resources, any compute resources that you provision, you can provision them to your that specific physical host. So this allows you to maintain the affinity between the host and instances. So specifically for PCI compliance, they actually look at dedicated physical host kind of a model. And they have added a variant between shared and dedicated host, which is referred to as a dedicated instance. So in this case also, Amazon would assign a physical host to your account. But the major difference is that the affinity between the host and instance is not maintained. So let's say this was the physical host that was assigned to me. So based on the capacities that were available to Amazon, Amazon might have dedicated a physical host that is much higher in capacities. So that is lost of dollar value to Amazon. So in that case, Amazon would go ahead and dedicate a physical host to your account. But when you stop the instance, so it would again check whether it has a physical host of lesser capacities. If it has, it is likely to place this instance, the next physical host. Again, this physical host would be dedicated to your account. So if your need is purely from compliance perspective, dedicated instance is the way to go. With respect to dedicated hosts, there's another benefit. So there are a lot of licenses that you actually are tied to specific physical hosts. So if as an organization you have already spent money on those licenses, you want to use them in AWS environment, you can always use that. So the default tenancy attribute is shared. That's only eligible under the free tier. If you choose dedicated or dedicated host, you'll be charged for it.
All right, now let's take a quiz question. And the question is, what is the primary function of Amazon EC2? And the options are A. Data storage, B. Compute resources for running applications, C. Database management, or D. Machine learning. And if you know the answer, please drop it in the comment section below. With your EC2 instance setup, let's move on to cloud storage, that is AWS S3, where your data can live securely and scale easily.
So what are the different AWS storage services? Now, when you talk about storage services, there are quite a few storage services. Let us quickly take a look at those one by one. So Amazon Elastic Block Storage is one of those storage services. What it does is it basically gives you storage in the form of blocks. Each of this block is connected to a particular system or an instance. So in order to access this memory or this storage, you have to make sure that you have an instance connected to it, and you can access it through that instance only. So that is one limitation of Elastic Block Storage. Otherwise, it is highly scalable. You can kind of detach, attach volumes to your instances at your will, and it is a very good storage service. Having said that, the other storage service is Amazon Elastic File System or Amazon EFS. Now, this again works on a similar mechanism that Amazon EBS works on, but the difference is it is a shareable or shared file system. Hence, it is not attached to a particular system or an operating system. Then you have Amazon S3 Glacier, which again is a storage system or a service which basically lets you store archival data. Now, what do I mean by this? Well, there is certain data that you would not want to retrieve or use on daily basis or on frequent basis. In that case, you can actually go ahead and put your data in a service like Glacier, because what it does is it basically locks in your data for a certain while during which you cannot access it. Once you've cleared that duration, you are free to access this data. But the other issue is it takes or gives you high amount of latency. That means you cannot access this data in real time or right away. It takes a while to retrieve this data. So why should you store your data at a place or in a storage like Amazon S3 Glacier? Well, the benefit of this storage is it is very cheap, or it is more affordable when you compare it with S3. And the fact that it has high latency, that is the reason it is cheap. What kind of data can you store here? Say, for example, the data that you might not require every day. If you talk about Indian systems or Indian hospitals, we normally have our birth certificates that are delivered by hospitals to us once a baby takes birth. So what happens is once you get this so-called birth certificate, it is not every day that you're going to go to the hospital and request for a new birth certificate. But the hospital still has to maintain a copy of your birth certificate. That is, in case if you need to get this document, probably they can give it to you. So that is why this is some data which is important, but it is not needed every day. So that kind of data can be stored in Amazon S3 Glacier. I believe I've made my point. I've gone a little vague or out of the way to discuss this topic, but I hope we are on the same line. Having said that, guys, the other storage systems are AWS Storage Gateway, which basically forms a gateway between two different platforms. Say, for example, my data lies on my on-premise architecture, and I need to move it to Amazon Storage Services. So what I can do is I can have this storage gateway that lets me move my data from that environment to this environment. So in simple words, it acts as a middle layer or a gateway for storing data or for moving data. Then you have Amazon S3 Storage. Before that, I would also like to mention a couple of other services which are not there on the screen. Say, for example, you have your Snowball, which actually lets you move your data physically. I mean, you would be having a device or a system in which you would kind of copy your data, move to the desired destination, and then paste it there. But this happens physically. In case if you want to move large amount of data, then you have other storage service by AWS called as Snowmobile, which is a moving data center which works on the similar principles. You copy your data from your existing environment into the data center. It is physically transferred to the main location, and from there you can move your data to the data center where you are planning to move it. And this might take 5 to 7 working days depending upon the location where you are planning to move the data, and a lot of other policies come into picture as well. So this was about the other storage services that AWS has to offer. There are a couple of other storage services that AWS still offers, and I haven't discussed those, but you are free to visit Amazon's official channel to know more about those. As far as today's topic is concerned, our main focus would be on S3 storage. So let us just move further and try to understand what the storage exactly is. So guys, when you talk about S3, now it is a simple storage service which is simple or easier to use in real sense. It lets you store and retrieve data which can be in any amount, which can be of any type, and you can move it from anywhere using the web or internet. So it is called as storage service of the internet. What are the features of this particular service? It is highly durable, guys. Now, why do I call it durable? It provides you durability of 99.999999, some 11.9. Now, when you talk about that amount of durability, it is understandable how durable this service is. What makes it this durable? It uses a method of checksum where it constantly uses checksums to analyze whether your data was corrupted at a particular point. And if yes, that is rectified right away. And that is why this service is so durable. Then it is highly flexible as well. As I've already mentioned, S3 is a very simple service, and the fact that you can store any kind of data, you can store it in any region or any available region is what I would mean by the sentence. it makes it highly flexible to store the data in this particular service. And the fact that you can use so many APIs, you can kind of secure this data in so many ways, and it is so affordable. It meets different kinds of needs, thus making it so flexible. Available. Is it available? Yes, definitely it is very much available. As we move into the demo part, I would be showing you which regions basically let you create these kind of storages and how can you move and store data in different regions as well. So if you talk about availability, yes, it is available in different regions, and the fact that it is so affordable, making it available becomes all the more easy. Cost efficient, yes. Now to start with, we normally do not get anything for free in life, but if you talk about S3 storage, AWS has a free tier which lets you use AWS services for free for 1 complete year. But this happens in certain limits. Now, when you talk about S3, you can store 5 GB of data for free, at least to get started or get used to the service. I believe that is more than enough. And what it also does is it lets you have somewhere around 20,000 get requests and somewhere around 2,000 put requests as well. So these are something that let you store and retrieve data. Apart from that, you can move in 15 GB of data every month outside of your S3 service as well. So if you're getting this much for free, it is definitely very much affordable. Also, it charges you on pay-as-you-go model. Now, what do I mean by this? Well, when I say pay-as-you-go model, what we do here is we pay only for the time duration that we use this service for, and only for the capacity that we use this service for. So that is why as you move along, if you need more services, you would be charged more. If you do not need more amount of the service, you won't be charged to that greater extent. So is it cost efficient? Definitely it is. Scalable? Yes. That is the best thing about AWS services. Most of them are scalable. I mean, you can store huge amount of data, you can process huge amount of data, you can acquire huge amount of data. If it is scalability that is a concern, you do not have to worry about it here, because even this service readily scales to the increasing data that you need to store. And the fact that it is pay-as-you-go model, you do not have to worry about the cost factor as well. Is it secure? Definitely it is. Now you can encrypt your data. You have various bucket policies as well that let you decide who gets to access your data, who gets to write data, who gets to read data. And when I said you can encrypt your data, you can actually go ahead and encrypt your data both on client side and on your server side as well. So is it secure? I believe that answers the question on its own. So guys, these were some of the features of Amazon S3. So guys, now let us try to understand how does S3 storage actually work. Now it works with the concept of objects and buckets. Now bucket, you can think of it as a container, whereas an object is a file that you store in your container. These can be thought of as AWS S3 resources. Now when I say an object, basically object is your data file. I've already mentioned that you can store any kind of data, whether it's your image, whether it's your files, docs, whatever it is. These are nothing but your data, and this data comes with metadata. When I say an object, it is combination of your data plus some metadata or information about that data. What kind of information? Basically, you have the key, that is the name of the file that you use, and version ID is something that tells you which version are you using. As we discuss versioning, probably I would talk about version ID a little more. But meanwhile, I believe this is more than enough. Your objects are nothing but your files with the required metadata. And the buckets, as I've already mentioned, these are nothing but containers that hold your data. So how does it work, guys? Well, what happens is basically you go ahead and create buckets in regions and you store your data in those regions. How do you decide what buckets to use, what regions to use, where to create the bucket and all those things? Well, it depends on quite a few factors. When I say I have to create a bucket, I need to decide what region would be more accessible to my customers or to my users, and how much cost does that region charge me, because depending upon the region, your cost might vary. So that is one factor that you need to consider. And latency as well. I mean, if you put your data in an S3 bucket that is far away from you, fetching it might cause high amount of latency as well. So once you consider these factors, you can create a bucket and you just store your objects. When I said version ID key, actually your system automatically generates these features for you. So for you, it is very simple. Create a bucket, pick up your object, put it in it, or just go ahead and retrieve the data from the bucket whenever you want to. So I believe this gives you some picture about what S3 is. Now let me quickly switch into the demo part and let me give you a quick idea or quick demo as to how S3 works, so that it is not too much theory for you people. So guys, what I've done is I've actually gone ahead and I've switched into my Amazon Management Console. Now, as I've already mentioned, AWS gives you a free tier for which you can use AWS services for free for 1 complete year. Mine is not a free tier account, but yeah, if you are a starter, you can create a fresh account. You just have to go ahead and give in certain details. All you do is you just go to your web browser, search for AWS free tier and sign in with the required details. They would ask you for your credit card or your debit card details. Enter any one of those for the verification purpose. And you can actually go ahead and set up alarms as well, which would tell you as in, okay, this is the limit to which you have used the services. And that way you won't be charged for access of data usage or service usage. Having said that, guys, this is about creating an account. I believe it is fairly simple. You can create an account. Once you create an account, guys, this is the console that would be available to you. What you have to do is you have to go ahead and search for Amazon S3. If you search S3 here, it would kind of redirect you to that service page. So guys, as you can see, this is the company's account probably. Somebody uses it in the company and they have their buckets that are already created. Let's not get there. Let us just go ahead and create our own bucket and just go ahead and put in some data into it. It is fairly simple, guys. I've already mentioned it is very simple to use kind of service. All I have to do is click on create bucket and enter in name for some bucket. Guys, now this name is unique. It is globally unique. Once you enter a name for the bucket, you cannot use the same name for some other bucket. So make sure you put in valid name. And the fact that I use the term global, something reminded me to be explained of. So guys, as you can see, if I go back here, I want you to notice this part. So guys, when you are into the management console or you open any service, by default, the region is North Virginia. Okay, so if I create a resource, it would go to this region. But when I select the service that is S3, you can see that this region automatically goes to global. That means it is a global service. It does not mean that you cannot create bucket in particular regions. You can do that, but this service is global is what they're trying to say. So let us just go ahead and create the bucket. Let us call it today's demo. You cannot use caps, guys. You cannot use some symbols. So you have to follow the naming convention as well. Today's demo. Sorry, I'm very bad at naming conventions, guys. I hope it is okay. Let it be in US East. You can choose other regions as well, guys, but for now, let it be whatever it is. So I'm gonna stick to North Virginia. There are 76 buckets that are being used. Let us just say next. Bucket name already exists. So this was already taken, guys. See, so you cannot use it. Let's call it, say, Ramos bucket 13113. Okay, do you want to keep all the versions of the object? We will talk about what versions are. Okay, guys. Meanwhile, you just bear with me. I'm just going to go ahead and create a bucket. Create a bucket. And there you go, guys. I'm sure Ramos bucket should be here somewhere. Here it is. If I open it, I can just go ahead and create folders inside it, or I can directly upload data. So I say upload, select a file. Let's just randomly select this file. It is Van Rossum, founder of Python, basically. Let's just say next, next, next. And the data is uploaded, guys. You can see the data being uploaded and my file is here for usage. So guys, this is how object and bucket kind of stuff works. You can see that this is the data that I have. If I click on it, I would get all the information. What is the key? What is the version value? For now, let's not discuss version, but this is the key or the name of the file that I've uploaded. So it is fairly clear, right, guys? So let us just quickly switch back to the presentation and discuss some other stuff as well. Now guys, another important topic that is to be discussed here is S3 storage classes. Now we've discussed how the data is stored or how buckets and objects work. But apart from that, we need to discuss some other pointers as well. As in, how does AWS charge me, or what kind of options do I have when it comes to storing this data? So it provides you with 3 options, guys: standard, infrequent, and glacier. Let me quickly give you an explanation to what do these storage classes mean and what all they offer to us. When I say standard, it is the standard storage which gives you low latency. So in case if there is some data that needs to be fetched right away, you can actually go ahead and use standard storage. Say for example, I wish to go to a hospital for certain kind of checkup. So in that case, my details would be entered in. And the fact that I'm getting myself checked in a hospital or diagnosed in the hospital, what happens is this data is important, and if it is needed right away, it should be available. So this kind of data can be stored in your standard storage where the latency is very less. The next we have infrequent access. Now, what do I mean by that? Now, in this case, my latency period has to be low because I'm talking about data that I would actually need anytime if I want to. But when I store this data for a little longer duration, all I want is this data to be retrieved quickly. Say, for example, I get a particular report or a particular test done. So in that case, I would actually go ahead and submit my details or say, for example, my blood samples, but I need this information maybe after 3 days. So what happens is in this scenario, I would want to store this data for a longer term, but the retrieval should be faster here. In the first case, that was not the case. If I needed that data right away, and if I wanted it to be stored for a very short duration, I would use standard. But if I want to store it for a longer duration and I want a quick retrieval, in that case, I would be using infrequent access. And finally, I have Glacier. We have already discussed this. Here, your retrieval speed is low and the data needs to be put in for a longer duration. And that is why it is more affordable. If you take a look at the stats that are there in the image above, you can see that minimum storage duration is nothing for standard. For infrequent, it is 30 days, and for Glacier, it is 90 days. If you take a look at latency, it is milliseconds, and 4 hours. So that itself explains a lot of stuff here. So what are storage classes and what do they do? I believe some idea is clear to you people. Again, as we move into the demo part, we would be discussing this part as well. And we would also discuss expiration and transition that supports these terms. But let us move further and try to understand something else first. Versioning and cross-region replication. Now guys, when I say versioning, I'm actually talking about keeping multiple copies of my data. Now, why do I need versioning and why do I need multiple copies of my data? I've already mentioned that AWS S3 is highly durable and secure. How is that? Because you can fix the errors that are there and you can also have multiple copies of your data. You can replicate your data. So in case if your data center goes down, a copy of it is mentioned or maintained somewhere else as well. How is this done? By creating multiple versions of your data. Say for example, an image, I store it in my S3 bucket. What happens here is there is key, the name is same, image, and version is some 33333, right? Now take a look at the other image. If I actually go ahead and create a copy of the first image, its name would remain same, but its version would be different. So suppose both of these images, they reside in one bucket. What these images are doing is they are having multiple copies or giving me multiple copies. Now, in case of image, not a lot would change, but if I have doc files or data files, in that case, versioning becomes very important because if I make changes to particular data, if I delete a particular file, a backup should always be there with me. And this is where versioning becomes very, very important. What are the features of versioning? By default, versioning is disabled when you say, or when you talk about S3, you have to go ahead and enable this versioning. It prevents overwriting or accidental deletion. We've already discussed that. You get non-concurrent version by specifying version ID as well. What do I mean by this? That means if I actually go ahead and create one more copy of the data and store it, so the latest copy would be available on top. But I can go to the versions option, put in the ID that belong to the previous version, and I can fetch that version as well. So what is cross-region replication? Now, guys, we've discussed versioning. Let us talk about another important topic, that is cross-region replication. Now, when you talk about S3, basically what happens is you create a bucket in a region and you store data in that region. But what if I want to move my data from one region or from one bucket in one region to other bucket in other region? Can we do that? Yes, cross-region replications let you do that. So what you do is you basically go ahead and create a bucket in one region, you create another bucket in another region, and probably you give access to the first bucket to move data from itself to the other bucket. So this was about versioning, this was about cross-region replication, and I believe we've also talked about storage classes. Let me quickly switch into the demo part and discuss these topics to little more detail. So guys, moving back, what we have done is we've actually gone ahead and created a bucket already, right? When you talk about what was the name of the bucket, it was Remos, if I'm not wrong. Yep. So if you click on the bucket name, Remos, what it does is it basically shows you these details, guys. Now you can see that your versioning is disabled, right? So if I click on it, I can actually come to this page and I can say enable versioning. That means a copy of the data that I create is always maintained. So if I go to Remo's bucket, or I just move back, okay, this interface can be a little irritating at times. You have to move back and forth every now and then. So guys, there is a file which we have stored. You can just take a look at this date first. It says that it is 2:35. That was the time when the object was moved. Let me just say that upload the same file. This was the file we uploaded. I say next, 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 upload. So guys, this file is getting uploaded. You can see the name of the file is still same. We have only one file here. Why? Because it was recently modified at 2:45. From 2:25 to 2:35, it got changed to 2:45. So it is fairly clear, guys, what is happening here. Your data is getting modified. And if you wonder as in what happened to the previous version, don't worry. If you click on this show option, you can see that both of your versions are still here, guys. This was created at 2:35 and at 2:45. So this way, data replication and data security works much better. So you can secure your data, you can replicate your data. So in case if you lose your data, you always have the previous versions to deal with. How does the previous version thing works? So guys, what happens is if I delete this file, what Amazon S3 would do is it would set a marker on top of this file. And once I delete it, if I search for that ID won't be available. Why? Because the marker has switched to the next ID now. So whatever I want to do, I can do with the next ID as well. So guys, one more thing that you also need to understand here is what happens to the file. I mean, I've actually deleted a file, but a version is there with me. Can I delete all the versions? Yes, you can specify the ID and you can delete all the versions that you want. You can also do one thing, that is you can set a particular life cycle for your files. When I say life cycle, you can decide as in, okay, now I have a file in standard storage. We've discussed these storages, right? Standard storage, infrequent, and glacier. What you can do with your lifecycle management is you can decide as an, okay, for a particular time duration, I want this file to stay in standard. Maybe after a while, I want to move it to infrequent, and after a while, I want to move it to glacier. Say, for example, there is certain data which was very important for me, but having used that data, I don't want to use it for next few months. So in that case, I can move to the substitutes or to the other storage classes where probably I won't be needing to use that data for a longer while. And doing that, I won't be paying for this data as I used to pay for the standard, because standard is the costliest of the three. So let us quickly see, can we do that, or how does it work at least? If I just go back, this is my file. I can actually just go ahead and switch to management. In that, I have the option of life cycle. If I click here, there is no life cycle. Add a life cycle. You can add a life cycle rule as well, guys. New, let me call it new, and let me say next. It asks me what do I want to do. You can add rules in lifecycle configuration to tell Amazon S3 to transition objects to another storage class. There are pre-request fees when using lifecycle to transition data to any other S3 or S3 Glacier storage. So which version do I wish to use? Current, I can say yes. Add transition, and I can select transition to this tier when after 30 days. And if I say next, it would agree. Expiration, you can select other policies as well. So guys, when I say transition, first thing what it does is it tells me what time to transition to which storage class. And expiration, it tells me when does this expire. So I can decide when to clean up the objects and when not to. Let's not do that for now. Let's just say next. Next. So guys, what will happen here is after 30 days, my data would move to standard 1A storage. So you can actually go ahead and decide whether you want to move to Glacier. In that dropdown, you had more options as well. I did not show you that, but it is pretty understandable. You can move to Glacier as well. So this is about life cycle, guys. One more thing, you have something called as replication. You can add replication as well if you wish to replicate your data. Cross-region replication. I believe, guys, I do not have access to do that because I'm using someone else's account for now. But let me just give you some idea as to what you can do to replicate your data. You can just go ahead and click on Get Started. So replication, to remind you people, it is nothing but a process of moving your data from bucket in one region to other bucket in some other region. So for that, I need to select a source bucket. So let us just say that this is the bucket that I have. Next. Now guys, in my case, I haven't created the second bucket. What you can do is you can just go ahead and create one more bucket. Once you create the bucket, you can select the destination bucket. For now, let us just say that this is a bucket that has been created by someone else. I'm not going to transfer data here, but let's just select this for the demo sake. This is the bucket that I have. See, it says that bucket does not have versioning enabled. This is very important point, guys. I showed you how to enable versioning, right? If you select the bucket, there is an option on the right side saying versioning. You can actually go ahead and enable versioning there. So once you enable versioning, you would be able to use this bucket. Do you want to change the storage class for the replicated objects? If you say yes, it would give you the option of selecting what storage class do you want to select, right? If you don't have to. You can say next. You have to enter an IAM role. If you do not have any, you just say create a role and then the rule name. In this case, I do not have any details about this and I don't want to create a role because this account does not belong to me. Sorry for that inconvenience, but you can actually go ahead and select create a role and just say next, and I'm sure that you can actually go ahead and your bucket starts working or your cross-region replication starts working. What happens after that is once you store your object in a particular file, you can actually move that object, not in a particular file, in a particular bucket. You can move that data from that bucket to the other bucket, and a copy of your data is maintained in both the buckets that you use. So this is what cross-region replication is, guys. I believe that we've discussed what are storage classes, we've discussed what is cross-region replication, and we've discussed versioning in general. Let us quickly move back to the presentation and discuss the remaining topics as well. So guys, I've switched into the presentation part. Till time we've discussed how cross-region replication works, we've discussed how versioning works, and we've seen how to carry out that process. The other important topic that we need to focus on is we've known like how to create versions, how to move data from one place to the other. But the thing is, what if I have to move data from a particular location to a location that is very far away from me and still ensure that there is not too much latency in it? Because if you're moving data from one location to a location that is far away from you, it is understandable that it would take a longer while. Why? Because we are moving data from internet. So the amount of data that you move and the further you move, it should take a longer while for that. So how do you solve that problem? You have S3 transfer acceleration. You can do that by using other services as well. We discussed Snowball and Snowmobile as well, but they physically move the data, and at times it takes n number of days to move your data. With S3 transfer acceleration, that is not the issue because it moves your data at a very fast pace. So that is a good thing. So how can you move your data at a faster pace? By using S3 transfer acceleration. Now guys, let us first understand what it is exactly. So what it does is it enables fast, easy and secure transfers of files over long distances between your client and S3 bucket. And to do that, it uses a service called as CloudFront and the edge locations it provides you. As I move further, I would be talking about what CloudFront is. Do not worry about it. First, let us take a look at this diagram. So normally, if you are moving your data or directly uploading your data to a bucket that is located at a faraway distance, I mean, suppose I'm a customer and I wish to put my data into an S3 bucket, which is located maybe a continent away from me. So using internet, it might take a longer while. Instead, what I can do is I can use transfer acceleration. So how is it different? Now guys, there is a service called as AWS CloudFront. What it does is it basically lets you cache your data. When I say cache your data, that means you can store your data at a location that is in the interim or that is close to your destination. Now this service is basically used to ensure that data retrieval is fast. Suppose I'm searching for a particular URL. What happens is when I type that URL, a request is sent to the server, it fetches the data and sends it to me. So if it is located at a very far location, it might take a long while for me to fetch the data. So what people do is they analyze as in how much requests are coming from a particular location. And if there are frequent and a lot of requests, what they do is they set up an edge location close to that particular region. So you can put your data, you can cache your data on that edge location, and that data can be fetched from that edge location at a faster rate. So this is how edge locations work. What transfer acceleration does is it basically puts in your data at the edge location so that it can be moved to your S3 bucket at a quicker pace. And that is why it is fast. So guys, this was about S3 data acceleration. Let us quickly move into the console part and try to understand how S3 acceleration works. So guys, I've switched into the console. S3 acceleration or data transfer acceleration is very easy thing to do. I do not remember the bucket name. I think it was Remos something. Okay, if I select this and open it, I can actually go to the properties part. Guys, there are other things that you might want to consider. You can come here and take a look at those as well. For now, I'm just gonna say go ahead and enable transfer acceleration. It is suspended. I can enable it. It gives me the endpoint as well, and I say save. So guys, what this means is if I'm putting my data into this bucket, it would be transferred very quickly, or I can use this bucket to transfer my data at a quicker pace by using data transfer acceleration by S3. Again, guys, I missed out on one important point. The fact that we have been talking about buckets and stuff like that, there is something important that I would like to show to you people. First, let us just go back and disable this part. I do not want it to have the transfer acceleration thing going. And I just wanted to show it to you people how it is done. I just say go back to suspended. And one more thing, guys, if you once you actually enable the transfer part and if you upload a file, you can see the difference in the speed. The problem is you need a third-party tool to do that. So you can actually go ahead and download a third-party tool as well. And using that, you can actually go ahead and see how it works. Having said that, I was talking about buckets in general. So let us just go back and go to Remos again. There you go. And I'm gonna copy the ARN. I'll tell you why. I've copied the ARN. Now, when I open this bucket, guys, we have quite a few things. Permissions, I talked about security, right? So you can decide public access as in who gets to access your bucket. So guys, you can actually go ahead and decide who gets to access what kind of buckets. Say for example, here in your block public access, you can decide who gets to access what data publicly. For that, you have access control lists. Using these ACLs, you can actually decide who gets to access how. Other thing you can do is you can just go ahead and create a bucket policy and decide who gets to access your bucket or who gets to put your data, delete your data, and do all these things. Let us just go ahead and create a policy. Now you can write your own policy or you can just use a policy generator, which again is a third-party tool. So I want to create a bucket policy for my S3. So let's just say S3 bucket policy. And what kind of effect I want? I mean, do I want someone to access my system or do I want to deny someone from accessing my system? I can decide that. So let's for now just say that I want to deny someone from doing something. And what I want that someone to do is to deny a particular thing for that person for all the objects. I mean, I do not want that person to access any of the objects that is there. So what I say is star. That means nobody should able to do anything to any of the objects that are there in this bucket. So it says star service Amazon S3. What action I want? I want to prevent someone from deleting an object. There you go. And this is the ARN. That is why I copied it. It should be followed by a / and a star. Add a statement. And I say generate policy. So guys, the policy has been generated. I just have to copy it. If I copy this thing and I go back to the console, if I paste it here, I can say save. It's saved. I'll save it again just to be safe. So guys, we have actually gone ahead and let me just go ahead and again go to Remos. So guys, now there is an object here. Let me just try and delete this object. If I just go to the actions part here and I say delete, see the file is still here. Is it the other version? No, it's not deleted. See, there's an error here. If I click on it, it says 100% failed. Why? Access denied, because I do not have the access to delete the object right now. Why? Because I've created a bucket policy, guys. So that is what bucket policies and ACLs do. They let you make your objects or your data more secure. And as you saw in the option, there are quite a few options that you have at your disposal, which you can choose from, which you can mix and match and decide as in, okay, this is what I want to do. I want to probably give someone an access to delete a bucket. I want to give someone an access to do this or do that. So guys, this was about S3 data transfer acceleration. And we've also seen how you create a bucket policy, how you attach it to your bucket and stuff like that. Now, let me just go back and kind of brush up this session or finish this session up with a use case so that you can probably understand the topics that we've discussed a little more. First, let us go back to the use case, guys. So guys, I've switched into my presentation console again, and we would be discussing IMDb Media. Now, for people who watch movies, they might know what IMDb is. It is a website that gives you details about movies. They tell you what are the movies that are nice. If you probably select or type a particular movie name, They would give you details about it, as in who were the actors, how was the movie, how was the review, a short snippet explaining you what the movie is about, its genre and stuff like that. Plus they have their own ratings to kind of gauge in the customers even better, as in IMDb being a popular site. And when they say that this movie is this person good or liked by these many people, people normally believe it. So they have that score as well. So if you talk about a website that basically deals with movies, you understand the number of movies that are released worldwide. And if most of them are present here on IMDb, that means that database is huge. But we are talking about data that is being processed in great numbers, great amounts. I mean, when you talk about the data that is here, what is happening here is you have n number of movies that are being released. So if someone searches for a particular movie, it has to go through the database and that data has to be fetched to him right away. So how do you deal with the latency issue? Well, this would answer a lot of questions, or it would sum up a lot of topics that we've discussed here. Let us go through this use case probably. So what happens here is, in order to get the lowest possible latency, all the possible results for a search are pre-calculated with a document for every combination of letters in the search. What this means is, probably based on the letters, you have a document that is created and it is traversed in such an order that all the data is scanned letter-wise. When you actually go ahead and put forth a query, what happens is, suppose if there is a 20 character letter or a word that you put in, so there are somewhere around 23 into 1030 combinations that are possible. So your computer has to go through these many combinations. What S3 does is, it basically lets you store the data that IMDb has. And once IMDb has stored that data, they use CloudFront again. We have discussed what CloudFront is. They use CloudFront to store this data to the nearest possible location, so that when a user fetches this data, it is fetched from that location. So what happens is, basically, when these many possibilities or combinations are to be dealt with, it becomes complicated. But in practice, what IMDb does is, it basically uses analytics in such a way that these combinations become lesser. So in order to search for a 20 character letter, they basically have to go through 150000 documents. And because of S3 and CloudFront, you basically can distribute all the data to different edge locations and to buckets within hours. And since we are talking about huge amount of data, it is more than terabytes. It is like hundreds, thousands of terabytes of data. So we can understand how much data are we talking about. And S3 actually features or serves a number of such use cases or requirements. So guys, I believe by now you've understood what S3 is. Let me give you a quick sum up or a quick walkthrough as to what we've studied, because we've talked about a lot of topics, guys. First, we started with the basics of different storage services. We've understood storage services like EFS, EBS, storage gateway. We've talked about Glacier, we've talked about Snowmobile, Snowball, and then we moved to S3. S3, we talked about buckets, we talked about objects, we talked about versioning. We understood why versioning is needed, so that we can basically replicate our data, prevent it from deletion, prevent it from corruption. We also talked about a cross-region replication, where you can move data from one region to the other. We talked about how we can move data faster by using S3 data transfer acceleration. And then we also took a look at basics like what are the storage classes, what are the bucket policies, how to create bucket policies. And we also discussed an important topic called as transition and expiration, where if your data expires, it is deleted. If your data needs to be transferred to different stages, you can do that as well. So all these topics were discussed, and we also discussed some important features. And finally, we finished this session up with a use case.
Now let's jump into a quick quiz question. And the question is, which of the following is not a feature of AWS S3? And the options are A, object storage, B, file versioning, C, data analytics, or D, bucket level security. And if you know the right answer, please drop it in the comment section below. Now that we have got data stored safely in S3, we need to ensure everything is secure. So that's where IAM comes in. Let's dive into how you can control who accesses your resources.
Why do we need access management? Alright, so to discuss this topic, let's understand it using an example. Say you have a company in which you have a server And this server has everything in it. It has all the modules in it, and it gives you it gives different users the permission to use the different servers, right? Now, in your company, first of all, you should have an administrator which will have all the rights to access the server, right? So nobody in the today's IT world works on the root account, right? So there has to be an administrator account. So first, we will create an administrator account with all the permissions. Now, tomorrow, say a UI developer comes into your company, right? Now, a UI developer will only work on the graphical tools, right? So he should only be allowed the graphical tools and not some other tools. Maybe he shall not be given the internet access or something like that, right? Maybe he's not giving the PowerPoint access. Maybe he's not given some folders access, some drives access, anything like that. So all of that can be defined in the server by the administrator, and specific rights will be given to a UI developer, right? Similarly, if after that a business analyst comes in, so he should only be able to access the analytics module which is there in your server, right? He should not be able to get into the UI development part, or he should not be able to see the other aspects of what is there in your server, right? So each and every user or each every role will have specific rights assigned to them, right? And this is done by policies which are in turn given by administrators, right? So this is what access management is, that giving each role the specific rights that they deserve. And this is what we are going to accomplish today in AWS, right? So this is why we need access management. Let's go ahead and understand how can we accomplish this in AWS, right? So to accomplish this in AWS, you need a service called IAM. You have a service called IAM which uses this concept of access management and allows you to give it to your users who are going to use your account, right? So what is IAM? So IAM is basically a service from AWS using which you can give permissions to different users who are using the same AWS account that you have created, right? So in a company in any company, be it, you don't have to have 2 or 3 AWS accounts. You can have one AWS account on which a number of people can work, right? For example, you can define that maybe a developer would like to work on your AWS account, and he should only have the EC2 instances, or he should only work on the EC2 instances. You decide that, right? So you can define a policy like that, that only the developers will only be able to access the EC2 instances on your AWS account. Similarly, if say a database administrator comes in, so he should be only able to access the DB instances on your AWS account, and so on, right? So all of that is possible using IAM. But IAM is not only about creating users and creating policies. There is more to IAM, right? And hence we'll be discussing the different components of IAM now. So let's go on and see what are the different components. So there are basically 4 different components in the IAM service. So the first service is user, then we have groups, then we have roles, and then we have policies, right? So the way we are going to go about these are, first I'm going to explain you each role or each service in IAM, each component in IAM, and then we're going to see how we can execute them or create them in the AWS console, right? So let's start with the users. So the very first time you actually create a AWS account, that is basically the root account that you have created, right? So there is no user inside it. So why do we basically need a user? You need a user because you are supposed to give permissions to someone, right? So say I first of all want to give administrator rights to a user, right? So you understand, you have to have an entity first to which you can assign permissions, right? So these entities are called users on AWS. So any person who wants to access your AWS account has to be added as a user in IAM, and then you can attach different policies onto that user. Alright, so this is what user is all about. Let me go to my AWS management console and show you how you can create a user in IAM. Alright, so give me a second. Alright guys, so this is my AWS sign-in page. Alright, so this email ID, when you log in through your email ID and your password, that is basically your root account. So what I'm going to do right now is I'm going to log in using my root account and first create a admin account for myself. Alright guys, so you should never work in your root account. You should always have an administrator account to work in. The root account should only be used when there is an emergency. Say you have been logged out of your administrator account, only then you should be using your root account. So the first thing that you should do when you enter your root account is go to IAM, which is just right here. Go to IAM and then you will have this dashboard thing, right? Over here you can see there is a thing called users. You will click on users and you will click on add user. Alright, so now it will ask you for the username, so you can provide a username. Say I'll add my name first, so that be Hemant, right? And what kind of access do I want to give to this particular user? So there are basically two kinds of access that I can give. First is the AWS Management Console access, and then we have the programmatic access, right? So what is these two? If you want to, so there are basically two ways you can access the AWS resources, right? You can either access them using APIs, that is using your code. Say you have created an application which is interacting with your AWS resources, right? So in that case, if you're interacting with the APIs, using the APIs, that is called the programmatic access. Right. Secondly is the AWS Management Console access. That is when you are using the AWS website to actually deploy resources or create or remove policies or whatever, right? So that is called the AWS Management Console access. So for my user, I'd be giving it both the accesses, that is programmatic access and the management console access. Also guys, when you enable the programmatic access, basically you get the access key and the secret key as well. What are these? I will be explaining you in a bit. Alright, so we have selected both of these options and then move ahead to choose the password. So do you want an auto-generated password or a custom password? I'll choose a custom password since I'm creating account for myself, right? So I'll choose a custom password. And do I want to reset the password on my first login? No, I don't want that. So I'll click on next permissions. All right, so what kind of permissions do I want my account to have? I will be configuring that over here. So as of now, there are no groups. There is no existing user that I can copy from. So I'll attach existing policies, and since I want to attach the administrator access, that is the first policy over here, I'll select that and click on next. Alright, so you can review all the settings that you did over here and click on create user. This will create a new user in your AWS account. So as you can see, I have got my access key ID and a secret access key. Now guys, the secret access key, you only get it to see one time, only one time when you have created your account. So it is essential that you store your access key and your secret access key once you get this page. All right, so let me store it quickly. So this is my access key ID. Why we are copying it, you'll get to know during the session. Don't worry. And my secret access key, which is this, so let me copy this and paste it in the notepad. Alright, so don't worry, you might be thinking that I've exposed my secret key to you, so I'll be deleting this account afterwards, so you don't have to worry about that. Alright, so I've got my access key ID and my secret access key, so that is done. Now what I'll be doing is I'll be logging out from my root account and logging in this user account that I just created. Alright, so one more thing that you have to be very careful of, that you will not be logging in through the same login page that you just saw, right? So you'll have to log in through a different login page now, and the URL for that is this, right? So you'll be logging in through this link as of from now on. So whenever you create a user, if you want them to log into your account, you have to give them this link to log into, right? So let us copy this link over here and log out from our root account. Alright, so I've logged out. I'll close this and I'll come here and go to this particular link. All right, so once you reach this particular link, it will be asking you the account name, which will be self-filled by your link, right? So you have to give your username now, which is Hemant, and then the password. So I'll type in the password that I've given it and click on sign in. So now I have basically signed in to the user that I've just created on my root account, right? So I no longer have to use my root account. I can basically lock away my root account for emergency purposes. I'll be using my administrator account from now on. I can do everything from my administrator account that could be done from my root account as well. But there are cases wherein you get locked out from your administrator account. In that cases, you will be needing your root access. All right. So moving on, guys. So I'll go to IAM now. So as you can see, we have created a user and we have logged into that user. And if I go to IAM now, you can see that it will show that one user has been created. That is here. All right. So let's get back to our slide and discuss the next component. All right. So we've discussed what are users. Let's move on to the second component, which are groups. All right. So whenever you create users, they can also be combined into groups. Now, why do we need groups? We need groups because say, let's take an example. So say you have 5 users and these 5 users have to be given identical access, right? Say these 5 users belong to the development team and the developing team has to have some common access that they all will have, right? Now, one way of doing this would be that I would go to each and every user and attach a policy that they need, right? The smart way to do this would be to include them inside one group, and to that group I will only once I will attach the policy and it will apply to all these 5 users, right? So these are why groups are very important. Now how we can create groups, let me shed a light on that. So you will go to you can see you can click on groups over here, and what you'll do basically is you'll click on create new group. All right, so let me give the group name as live demo. All right, and I'll click on next step. Now it will ask me the policy that I want to attach to this particular group. All right, so say for example, I just want this group to be able to access the S3 service from AWS. So what I'll do is I will select the policy which says Amazon S3 full access, and I'll click on next step. Now this policy basically tells you that you're going to only use the S3 service in the management console and no other service. All right, so I'll click on create group, and now whichever user I will be putting inside this group will have this property. All right, so I don't have to configure the policy for any user now. So what I'll do is I'll create a new user now. So say I create a new user saying test. All right, and then I'm not giving him the programmatic access, I'm just giving him the management console access. All right, I'll click on this and I'll give it a custom password, and then I don't want him to reset his password. I'll click on next, right? And now it is asking me whether I want to include it inside a group. So yes, I do. I want to include it inside the group that I've just created, and I'll click on next and review all the settings that I've just did and click on create user. All right, so the test account has just been created. Now, as you can see, guys, in the case of my account, which I created, I got an access key and a secret access key, right? So in this case, I'm not getting any because I didn't select the programmatic access. Only when you select the programmatic access, it will give you the key so that your application can actually interact with the services that you have launched. All right, so I've created a test user successfully. Let's log into this test user. So I will type in the URL that has been given to me. Right, now when I'll reach this page, I'll enter the username as test and the password as what I have entered, right? And I'll click on sign in. Now with this, you can see that I will now be able to see the management console. The management console will exactly look like how it was used to see, how I used to see it in my root account or my administrator account. But when you will try to access, say, a service which you have not been assigned to, say for example, I only have access to S3 right now because I've deployed it in the group where it has only the access to S3. If I try to go inside EC2, let's see what will happen. Right, so it says you're not authorized to describe running instances. As a matter of fact, I'm not authorized to see anything on my EC2 page. All right, so that is because I don't have access to the EC2 dashboard. But let's see if I can see the S3 dashboard. So I'll quickly go to S3. And if I have the S3 access, I'll be able to see all the buckets which are there in my S3. And yes, I do. So let me go inside a bucket and delete something so that, all right, so let me delete an object from this particular bucket. So yes, I can delete it. All right, so let me check if what happens if I delete or I detach this particular policy from that group. All right, let's see what happens. So I'll go to IAM and I'll go to groups. I'll go to this particular group and I can see that the policy is listed over there. What I'll do is I'll click on detach policy and let's see what happens now. Right, so I'll go to management console. So if now I try to access S3, it will show me that access is denied. Right, so I no longer have access to the S3 service on my AWS console. So this is how you can control access to different users. You can revoke access, you can include access, right? You can do all of that in IAM. All right, so let us come back to our slide to discuss our next component. All right, so we've discussed what are users, we've discussed what are groups. Now let's come down to roles. All right, so roles are similar to users, but roles are actually assigned to applications. All right, so users are actually assigned to people, right? So whenever you have a developer in the company, you will assign him the developer roles, right? But when you have roles, roles are basically assigned to applications. How? Let me explain you. Say you create an EC2 instance, and inside that EC2 instance, you're hosting a web application. Now that web application has been designed in such a way that it has to interact with your S3 services, for example, that we'll be doing today. I'll be showing you the demonstration today for this, right? So say that application has to interact with the S3 service. Now, if I want that application to interact with the S3 service, I have to give it permissions. And to give it permissions, I will use role. So I will create a role wherein I will specify that this role can access the S3 service, and I will attach this particular role to that particular EC2 instance in which my application is hosted. And in that case, my application will be able to interact with the S3 service. Right? It might sound complicated, guys, but it is very easy to implement. Let me show you how. So what I'll do now is I'll go back to my management console, which is here. All right, I'll go to the dashboard and say I'll go to roles now. All right, so I'll create a new role. Now roles can be assigned to any AWS service which is listed here. What I'll do is I'll assign it to, I'll create a role type of EC2. All right, so I'll select Amazon EC2. And what type of role do I want to apply it to? I want to say have the access to S3, right? So I'll select Amazon S3 full access over here and I'll click on next step. So it'll ask me the role name. So let me specify the role name as Edureka_1, right? And I'll click on create role. So with this, a role has now been created, but mind you guys, I've not attached this role to any EC2 instance, right? So what I'll do now is I'll go to my EC2 console. So over there, I already have built an EC2 instance. It is stopped, so I'll start it and attach this particular policy to that EC2 instance. All right, so my EC2 instance name is Hemant_1. So here it is. I'll go to actions, I'll start this particular instance. right? And what I can do is I can attach the policy using instance settings. It says attach or replace IAM role. I'll go here. I will go to the drop down and select the role that I've just created, which is Edureka_1. I'll select that and I'll click on apply. Now with this, what will happen is my role is now my EC2 instance is now configured to interact with the S3 service in this particular account. Alright, so any application that I deploy in this EC2 instance will be able to interact with the S3. Okay, so I don't have to specify any access key, any secret access key. If you're still confused with that, be patient. We are getting on to where do we actually use these keys and where do we not. All right, so this is what your roles are all about, right? So roles, like I said, they are for resources in AWS. Users are for people. Roles and users are similar things. You attach policies onto them and they basically identify a particular instance or a particular person as the owner of that particular service, right? So I've discussed what roles are. Let's move on and discuss policies. So if you think about it, guys, we've actually been dealing with policies, right? So policies are nothing but permissions that you give to your with whatever role or user or group that you have created, right? So for example, I want to give the EC2 instance access, right? So that EC2 instance access is basically a policy that I'll be attaching to the user or to the roles. All right, let's see how we can create policies, guys. So I'll go to my management console. I'll go to IAM. Right, so you can either create policies or you can actually use the already existing ones. So there are a couple of policies that have already been created in your AWS account, but you can go ahead and create your own policy as well. All right, so let me show you how. So say for my test account, what I'll do is I will go inside test account. Alright, and I will add permissions and I will attach existing policies directly, and here I am, guys. So now you can create policies as well. So you see the tab over here, guys, it says create policy. So if you feel the kind of policy that you want to create is not listed over here in the default policies, you can actually create one. And creating a policy is very easy, guys. You'll just click on create policy and you will see this page. Alright, so you'll have three options. You can either copy an AWS managed policy, that is a default policy. You can create your own policy by just typing in the JSON code. And if you're not comfortable with coding, what you can do is you can use the policy generator. Now, what is policy generator? Let me explain you. So with policy generator, you just have to select what effect do you want. Do you want it to allow it or do you want it to deny it? Right? So say I want to allow the EC2 service to this particular test account. All right, so I'll go to EC2. All right, here it is. I selected EC2. What kind of actions can he perform? Say I want to give him all the actions. You can do anything with EC2, and resource name is basically a particular resource. So with ARN you can identify a particular resource. So I don't want a particular resource to be assigned to him. I want he can access every resource in EC2, right? So I just add star for all of them, right? And click on next step. So with this, as you can see, it has automatically created a policy document for you. All you have to do now is click on create policy and it will create the policy for you. So as you can see, there were 18 customer managed policies. There are now 19. So I can go here and select the policy over here. All right. So if I go to my user now, which is test, and go to permissions, I will just click on add inline policy, click on select, again go to EC2, select actions, all actions, right, and put it to star. So I'll click on add statement, click on next step, and click on apply policy. So a policy has been applied on the test user that it can actually access the EC2 instances now. So if I go to my test user now, in which I was not allowed to access the EC2 instances, I can actually use the EC2 instances now. So if I go to EC2, you can see it will not give me the access denied thing, right? So I can access all the instances over here as if I was using the root account, but only for the EC2 service, right? If I go to S3, you can see I will still have the access denied page because I've not been assigned the access to this particular service. All right. One more thing, guys. What if you add an allow and a deny policy together inside a group? What will happen then? So in that case, so since I have allowed EC2 access, what I'll do is I'll deny EC2 access as well in this particular user. So I'll create one more policy and I'll say deny. I'll select EC2. Right, I'll select the actions as all actions. I'll give the resources all, add the statement, and click on next step, apply the policy. So now I have denied EC2 instances as well and created and allowed EC2 instances as well. What do you think will happen now? So if now I try to go to EC2, let's see what will happen. So it will say you're not authorized to use EC2 anymore, because whenever you're creating policy, guys, you either get the allow option or the deny option. If you have selected both of them, it will always prefer the least permission that you have given. So in our case, that is the deny option, right? So it will always deny the case even if you have allowed it in the same user, right? If you have mentioned that that particular service has to be denied to that particular user. All right, so this was about policies, guys. Let me come back to my slide. So we have discussed what are users, what are groups, what are roles, and what are policies. Let's go ahead and discuss the very important part of authentication, which is called the multi-factor authentication. So what is multi-factor authentication, guys? So multi-factor authentication is basically something like OTP that you get when you're logging into your Gmail account, right? So you enter your Gmail email ID, you enter your password, and when you click on continue, it'll ask you for your OTP, right? So same is the case here as well. You can configure your AWS account in such a way that you will enter your username, you'll enter your password, and when you click on login, it'll also ask you for a code that has to be given to it. Now that code is basically the multi-factor authentication thing that we're talking about. So there are basically two layers of security now. One layer is a password and second layer becomes the code that you'll be entering, right? Now with AWS, there is an application called the Google Authenticator, right, which you can use to create a virtual multi-factor authentication device. Now, for those of you who already are using multi-factor authentication in your companies, so there's a thing called Gemalto, right? So people who work from home and they have to connect to their company's network, the way you connect it is using a Gemalto token, right? And so those of you who are from the IT background, you can relate to it, right? But if you want to go through a simpler way, you can actually create a virtual multi-factor authentication device. And to create that in your AWS is pretty simple. You just have to download an application called Google Authenticator on your phone, and you have to connect that application to your AWS account, and that is it. Now it might sound tough, but it's very simple. Let me show you how. So you will basically go to your AWS Management Console, and you will go to the particular user that you want that multi-factor authentication to be assigned to. All right. So for example, I want it to be assigned to the test user, right? So what I'll do is I'll go to users, I'll go to test, right? And in the security credentials tab, I will have this page which says assigned MFA device. So it says no as of now. So I'll assign it a device. I'll click on edit. And now it will give me an option between a virtual MFA device and a hardware MFA device. Now I have to choose among the two. So since I said you can create a virtual MFA device very easily, so I'll select the virtual MFA device. and now it is basically asking you to install the application on your phone. So we have already done that. Let's click on next step, and now you'll be presented with the screen. So basically now what you have to do is you will be logging into your Google Authenticator app, and you will be scanning this barcode from your phone. So let me show you how. Let me connect my phone to the computer so that you can see the screen. Give me a second. Alright, so this is a screen to my phone, guys. So what I have to do now is I'll have to go to the Google Authenticator app, and it'll ask me to create an account. So I'll click on begin, and once I have that, basically now I'll have to scan the barcode from my mobile. So the way to do that is I'll click on scan a barcode, and then I'll scan this barcode over here. Right, it might take some time, so be patient. Yeah, so it's done. Now you're all set, right? So you'll just click on done, and now you have to enter two codes that you will be receiving on your Google Authenticator. So basically these codes change from every 30 seconds, right? So I have to enter these codes over here. So it's 204 and then 020 and 353. 020-353, and I have to enter the next code as well. So let's wait for the next code, and it's 127891. So I'll enter that over here as well. So it's 127891, and that is it, guys. So now I'll click on activate virtual MFA, and it says the MFA device was successfully associated. So I'll click on finish, and that is it, guys. You're done. Right, so now if I log out from my test account, that is from here, right? This is my test account. So if I log out from here right now, and try to log in again using test, so I'll come to my normal login page, right? So I'll enter my username and my password, which is this, and now I'll click on sign in. So now it'll ask me for the MFA code. So let's see what is our MFA code as of now. So it has changed to 734552. So let us enter that, 734552, and click on submit. So with this, I'll now be able to log in to my AWS console using the test account, which I configured using the administrator account in IAM. Alright, so it's very simple, guys. You can actually get world-class security with the click of a button using IAM. Alright, so we have seen how we can do multi-factor authentication. Let's move on to the hands-on part now. So this is what you guys have been waiting for. So just give me a second so that I can configure everything on my end. Alright, so what we'll be doing now is I have created an application which can interact with the S3 service. Alright, so using that S3 service now, we'll be uploading files to our S3 console. And how we are going to do that? First, we are going to do that using localhost, and that is where our secret keys and my access key comes in. And then we have assigned a role to our EC2 instance, right? So we'll be accessing that website using EC2 without the access key and the secret access key, and we'll see, do we get the access to our S3 service or not? All right, so let us do that. So now what I'll do is I will go to my localhost application. So guys, this is basically my application. What I have to do is I'll choose a file, I'll upload a picture from any sample pictures, and then it'll upload it to a particular bucket that I've defined in S3, and that the bucket looks something like this. Right, so that bucket's name is quarantine demo. So let me show you the bucket. So as of now, I think there are some objects. So let's delete those objects. So here it is. This is the bucket quarantine demo. So I have like 3 objects over here as of now. So let's delete these objects. Alright, so now what I'll be doing is, this is the code for my application, guys. Alright, so in this code, as you can see, I have not specified the key and the secret key as of now. So I'll get the key and the secret key from here, right? So let me show you without the secret key and access key how is this localhost website functioning. So if I try to upload a file as of now, say this is the file that I want to upload, I'll click on upload image and I'll get an error, right? Because it is not authenticating itself to the service that I want to go to. So now I'll add the credentials, that is the key and the secret key. Now the way to do that is like this. So I'll copy it and I'll paste it here. I'll delete this and this as well, not required. And now I'll paste my key and my secret key, which is this, right? So I'll copy the key over here and then my secret key as well over here. And now I'll save it, and if I try to access my localhost website now, I should be able to upload a file, right? So if I try to upload the file now, it says well done, S3 upload complete. So these credentials that I've just entered are basically credentials for my Hemant account. So if you want to see where did I get these credentials from again, you can basically go to users, you can go to your user and you can go at security credentials, and over here it will list you the access key ID. It will not list you the secret access key because it is only available once. You can only use it once, copy it once, you will not be able to see it again. And if I make this particular key inactive from over here, and if I try to upload anything again, I will again get an error because without the keys my account will not be authenticated to the S3 service. So as you can see, it says invalid access key because it is not valid anymore. All right, so I can make it active again, but that is not required as of now. So what I'll do now is I've already configured this website on the EC2 console. All right, so let me go to my EC2. Right, here it is. So remember in the starting of the session we created a role for S3 full access, right? So that role has been attached to my EC2 instance. So let me show you the website. Here it is. Alright, so I can access the website on my EC2. Now if I choose a file as of now and I try to upload the file, I'll be able to do so because my policy has been attached. Now let's see what happens if I attach the policy, right? So I'll go to this and I'll select no role, click on apply, yes, detach, and now if I try to upload a file again, as you can see, I see a blank page, which basically means that an error has occurred. All right, so I am not able to upload any file because my role has been detached from my EC2 instance. So if I want it to be working again, I'll just simply go here, go to actions, settings, attach the role, that is this, click on apply, and it'll again work. Right, I'll choose a file, say this file, upload the image, and it'll work again. Works like a charm, right? So that is it, guys. You don't have to configure much. You just have to have the knowledge of IAM, and with that you can do complex procedures with the click of a button, and you don't have to swear about it. All right, you might be wondering, did I change anything in the code when I uploaded it to EC2? So you don't have to do anything, guys. You just have to delete the credentials, key, and secret, and you will upload the code as it is. You don't have to change anything. If it doesn't have the key mentioned in this particular function, it'll basically get those keys from the metadata of EC2, and metadata is the place where your role is actually assigned, or your role is actually attached, right? So if it doesn't find the key in the code, it basically goes to the metadata and picks the key from over there.
Now it's a time for a quick quiz. So let's test your understanding. And the question is, which of the following actions is performed in AWS IAM? And the options are A. Managing EC2 instance types, B. Creating storage buckets, C. Setting user permissions for AWS resources, or D. Running virtual machines. Do let me know the right answer in the comment section below. And lastly, if you're thinking of taking your AWS skills to the next level, let's talk about AWS certification process. How you can prove your expertise and open doors to career opportunities.
Let me ask you a quick question. Have you ever thought about how companies like Netflix, Airbnb, or Spotify manage their data, run their application, and scale so efficiently? The secret lies in the power of the cloud. And for many top companies, AWS is a backbone of their success. With 63% of IT professionals finding it tough to recruit cloud talent, AWS certifications are your gateway to a high-demand career. Salaries for AWS roles in India are around 10 lakh rupees, and in US they reach up to $120,000. Cloud jobs are set to grow by 28% in the next 5 years. According to Gartner, by 2025, 51% of IT spending will shift to the public cloud. So if you're looking to future-proof your career, AWS certification could be the ultimate step forward. So, let's understand what exactly is AWS certification now. AWS certification is a program designed to validate your skills and expertise in using Amazon Web Services, or AWS, the leading cloud computing platform powering businesses and applications worldwide. AWS offers a wide range of cloud services, from storage and computing power to machine learning and artificial intelligence. And AWS certification shows that you have the knowledge to leverage these tools effectively. Now we'll understand why is AWS certification important. So, why should you care about AWS certification? Well, it's industry recognized and highly valued by employers. Getting certified proves to potential employers that you have the skills needed to design, implement, and manage cloud-based solutions using AWS. And trust me, that can set you apart from other candidates. Whether you're looking to switch careers or advance your current role, AWS certification can open doors to new job opportunities, career advancements, and even higher salaries. Next, let's explore the various AWS certification levels and what they entail. AWS offers a total of 12 certifications across 4 levels: Foundational, Associate, Professional, and Specialty. Each level caters to different expertise, from beginner to advanced cloud professionals. Here's a quick breakdown of each category. First, we have the foundational level. This is a knowledge-based certification for those who want a foundational understanding of AWS Cloud. The best part, no prior experience is needed for this level. There are 2 certifications here, the AWS Certified Cloud Practitioner and the AWS Certified AI Practitioner. These are perfect for beginners looking to get started with AWS. Next is the associate level. These are role-based certifications that showcase your knowledge and skills on AWS, helping you build credibility as an AWS cloud professional while no AWS experience is needed. Some prior cloud or strong on-premises IT experience is recommended. This level includes 5 certifications: AWS Certified SysOps Administrator Associate, AWS Certified Developer Associate, AWS Certified Solutions Architect Associate, AWS Certified Data Engineer Associate, and AWS Certified Machine Learning Engineer Associate. Moving on to the professional level. These certifications validate advanced skills needed to design secure, optimized, and modern applications on AWS, as well as to automate processes. For this level, AWS recommends at least 2 years of prior cloud experience. Here, we have AWS Certified Solutions Architect Professional and AWS Certified DevOps Engineer Professional. These exams are for advanced users who can handle complex AWS environments. Finally, there is a specialty level. This level lets you dive deeper and become a trusted advisor in specific strategic levels. For these certifications, check the exam guides on AWS sites for the recommended experience. Specialty certifications include AWS Certified Advanced Networking Specialty, AWS Certified Machine Learning Specialty, and AWS Certified Security Specialty. Each of these focuses on a particular field within AWS, giving you an edge in specialized roles. Whether you're just starting or looking to specialize, there is an AWS certification that's right for you. So first, let's see the foundational level certification. Let's dive deep into the details of the AWS Certified Cloud Practitioner certification. Starting with the category. This certification falls under the foundational level. It's aimed at individuals who want to get a higher level understanding of AWS Cloud, even if they are new to IT or cloud computing. Then we have the exam duration. You'll have 90 minutes to complete the exam. Exam format is that the exam consists of 65 questions. You'll see a mix of multiple choice and multiple response questions. The cost of the exam is $100 USD. Remember, pricing may vary slightly with foreign exchange rates. So check AWS exam pricing for up-to-date details. Then, where to take the test? You can take the exam at the Pearson VUE Testing Center or through an online proctored exam. The certification is accessible in multiple languages, including English, Japanese, Korean, etc. Now we'll cover what the AWS Certified Cloud Practitioner exam tests on you. You'll need to know these points as well. First, explain the value of the AWS Cloud and how it benefits organizations. Understand the AWS Share Responsibility model to know what responsibilities lie with AWS and what remains with the customer. Understand security best practices for keeping data and also applications secure. Understand AWS cloud costs and billing practices to effectively manage and forecast cloud expenses. Describe core AWS services like compute, network, database, and storage. Lastly, identify AWS services for common use cases to solve different business problems. To prepare for the AWS Certified Cloud Practitioner exam, here are the key concepts you should have the basic understanding of. First, AWS cloud concepts for a broad understanding of the cloud. Security and compliance in AWS, including best practices to safeguard data. Core AWS services that are most commonly used. And last is economics of AWS cloud to understand costs and also value. Now let's see the job tasks that are out of scope. For this exam, you are not expected to perform technical tasks like coding, designing cloud architectures, troubleshooting, implementing, or load and perform testing. And that's the overview of AWS Certified Cloud Practitioner certification. It's an ideal starting point for anyone looking to build foundational cloud skills and understand AWS at a higher level. Now let's see the AWS Certified AI Practitioner. Let's take a structured look at AWS Certified AI Practitioner certification, especially if you're aiming to validate your skills in artificial intelligence and machine learning on AWS. The category is the certification fails under the foundational level. It's meant for individuals who work with AI and ML technologies on AWS, even if they're not directly building solutions. The exam duration is 90 minutes. The exam format is you'll encounter 65 questions, covering multiple choice and multiple response types. The cost for the certification is $100 USD. As always, check AWS official pricing page for any variations based on exchange rates. And then, intent candidates. This certification is perfect for those who may not necessarily build AI ML solutions but are familiar with these technologies on AWS. Testing options are, you have flexibility here. You can take the exam at the Pearson VUE Testing Center or through an online proctored exam. Next, languages offered. The exam is available in English, Japanese, Korean, and so on. This certification validates your understanding of in-demand concepts in artificial intelligence, machine learning, and generative AI. This can sharpen your competitive edge and position as well for your career growth and better earning opportunities. Now let's get into what this exam covers. Candidates are expected to demonstrate the ability to understand AI, ML, and generative AI concepts, methods, and strategies, particularly how they apply on AWS. Ask relevant questions within their organization to determine the best uses of AI ML technologies. Determine the correct type of AI ML technologies for specific use cases. Lastly, use AI ML and generative AI technologies responsibly to ensure ethical and effective deployment. Next, let's see the recommended AWS knowledge. Although you do not need extensive AWS experience, familiarity with a few key areas can be helpful. Those are core AWS services like Amazon EC2, S3, AWS Lambda, and SageMaker. An understanding of AWS's shared responsibility model, especially around security and compliance. AWS identity and access management for resource access control. Lastly, knowledge of AWS's global infrastructure and service pricing models. Now let's move on to job tasks that are out of the scope. For this exam, you won't be expected to perform technical tasks such as developing AI ML model, conducting data engineering, hyperparameter tuning, and implementing security protocols for AI systems. This certification focuses on more practical AI ML knowledge rather than hands-on development. Now let's look at the exam content. The exam includes a mix of question types to assess your knowledge, such as multiple choice and multiple response questions, where you'll pick one or more correct answers. Ordering questions, where you'll arrange responses in the correct sequence. Matching questions, where you'll match items based on prompts. Lastly, case studies, where you'll analyze a scenario with multiple questions to assess your applied knowledge. And that's a structured look at the AWS Certified AI Practitioner certification. Perfect for professionals seeking to deepen their understanding of AI and ML concepts on AWS and to start their AI journey on a solid foundation. Now let's dive into the AWS Certified Solutions Architect Associate certification. This is one of the most popular AWS certifications and an ideal choice if you're looking to deepen your cloud architecture skills. The category of the certification is at associate level, perfect for those with foundational AWS knowledge or IT experience, whether in the cloud or on-premises. The exam duration is you will have 130 minutes to complete the exam. The exam format includes 65 questions, mostly multiple choice or multiple response. The cost is $150 USD. Be sure to check AWS's official pricing page for any regional cost variations. The testing options are, you have the option to take this exam at the Pearson VUE Testing Center or through an online proctored exam. The languages that they offer is, this exam is available in English, French, German, Italian, and so on. This certification is designed for those who want to architect cost-optimized, high-performing cloud solutions on AWS. Let's cover the core skills the exam assesses. Candidates should be able to design solutions with AWS services to meet current and projected business needs. Develop architectures that are secure, resilient, high-performing, and cost-optimized. Lastly, review existing solutions and identify areas for improvement. And next, target candidate description. The ideal candidate should have at least 1 year of hands-on experience designing cloud solutions using AWS services. Now understand the exam content. There are two main question types on the exam. Multiple choice, where you'll select the one correct answer. Multiple responses, where 2 or more answers may be correct out of 5 or more options. One more important thing is, unanswered questions are scored as incorrect, but there are no penalty for guessing. Remember, the exam includes 50 scored questions and 15 unscored questions. AWS gathers data from these unscored questions to evaluate them for future use, and they won't affect your overall score. Next, about the exam results. The exam is scored on the scale from 100 to 1000, with a minimum passing score of 720. This compensatory scoring model means you do not need to pass each section individually, only the overall exam. Your results will include a classification of your performance in each section, giving you insight into your strengths and areas to improve. Some sections carry more weight, meaning they have more questions and can impact your score more heavily. Moving ahead, let's explore AWS Certified Developer Associate certification. This is a key certification if you are looking to enhance your skills in AWS cloud development. The category is The certification is at associate level, ideal for developers who are ready to showcase their cloud development skills and understand AWS environments. The exam duration is 130 minutes long. The exam format is, it consists of 65 questions including multiple choice and multiple response formats. The cost of this exam is $150 USD. Check AWS's pricing page for additional regional cost details. The testing options are, you can take this exam at a Pearson VUE testing center or through an online proctored option. The languages offered are, this exam is available in English, Japanese, Korean, and so on. The AWS Certified Developer Associate Certification validates your skills in developing, optimizing, packaging, and deploying AWS applications. It's great for anyone starting out in AWS or working in IT or cloud development roles. This exam is designed to assess the skills like, we'll break down what skills the AWS Certified Developer Associate exam is designed to assess, including developing and optimizing applications on AWS, deploying applications using CI/CD workflows, securing applications code and managing data protection, identifying and resolving application issues. The target candidate description is, ideally candidates that have 1+ years of hands-on experience developing application using AWS services. Now let's see the recommended AWS knowledge. You should know how to develop and secure applications using AWS Service APIs, the AWS CLI, and the SDKs. Use a CI/CD pipeline to deploy applications on AWS as well. Now let's see out-of-scope tasks. This exam doesn't cover some tasks like designing architectures. Let's understand exam content. The questions are a mix of multiple choice and multiple response types, where you need to choose one or more correct answers. There are 50 scored questions that affect your final score, and 15 unscored questions to evaluate your future use. Moving forward, let's dive into the AWS Certified SysOps Administrator Associate Certification. This certification is perfect for those in a cloud operations role and looking to prove their skills in monitoring and maintaining AWS workloads. The category is, this certification is at associate level, ideal for system administrators or those focused on AWS cloud operations. The exam duration is 130 minutes long. The exam format includes 65 questions with multiple choice and multiple response types. The cost for the exam is $150 USD. For additional pricing details, check the AWS website. The testing options are, you can take the exam at the Pearson VUE Testing Center or online through a proctored exam. The languages that they offer is, the exam is available in English, Japanese, Korean, and simplified Chinese. The AWS Certified SysOps Administrator Associate Certification validates your expertise in monitoring AWS workloads, implementing security controls, and applying networking concepts. It's ideal if you are in an IT role involving AWS cloud administration. Now we'll walk through the core areas this exam covers, including supporting and maintaining AWS workloads based on AWS well-architectured framework, operating workloads using the AWS Management Console and CLI, implementing security controls for compliance, monitoring, logging, and troubleshooting AWS systems, applying networking concepts like DNS and TCP IP. Lastly, performing business continuity and disaster recovery procedures. The target candidate description is, ideally, candidates have 1 year of hands-on experience managing AWS workloads, with skills in networking, security, and troubleshooting. The recommended AWS knowledge and experience are, candidates should have at least 1 year of experience with AWS technology, proficiency with the AWS Management Console and CLI, and an understanding of the AWS well-architectured framework. Now, about the exam content. The questions are a mix of multiple choice and multiple response, with 50 scored questions that impact your score and 15 unscored questions that AWS uses for future testing. Now, the another certification, so-called AWS Certified Data Engineer Associate exam. If you are looking to prove your skills in managing data on AWS, this certification is for you. The exam is an associate level certification, so it's perfect for those with some experience in data engineering, but not quite for experts. You have 130 minutes to complete the exam, which is about 2 hours and 10 minutes. There are 65 questions in total. Some will be multiple choice and some will be multiple response. The cost is $150 USD. Now let's see where you can take it. You can take the exam either at a Pearson VUE test center or online with a proctor watching you from home. The exam is available in English, Japanese, Korean, and simplified Chinese. Basically, the certification is all about working with data on AWS. The exam checks your skills in tasks like ingesting and transforming data, getting data ready for use, creating data pipelines, that is orchestrating how data moves and changes, designing data models, making sure data is organized in the right way. Lastly, maintaining data quality, keeping your data clean, secure, and properly governed. The exam also tests your ability to monitor and optimize data pipelines, ensuring things run smoothly and cost-effectively. Who should take the exam? The exam is meant for people with about 2 to 3 years of experience in data engineering and at least 1 to 2 years of hands-on AWS experience. What you should already know. You should know how to set up and maintain ETL pipeline, that is extract, transform, load for data. Use basic programming concepts to build these pipelines. Understand how to use Git for version control and data lakes for storing data. Lastly, have a general understanding of networking, storage, and computing. In AWS, you should know how to use AWS Services to build and manage data pipelines. This includes things like encryption, data protection, and logging. You should also be able to write SQL queries on AWS Services to analyze data. Moving ahead, understand about the certification exam. This exam will have 2 types of questions. Multiple choice, in which one correct answer is given. Multiple responses, where you'll need to pick more than one correct answer. Next we have is AWS Certified Machine Learning Engineer Associate. Alright, let's break down what you need to know for AWS Certified Machine Learning Engineer Associate exam. The duration and questions are, you'll have 130 minutes to complete 65 questions. The cost of the exam fee is $150 USD. Where to take the exam? You can choose to take the exam either at a Pearson VUE test center or online with the proctor. The exam is offered in English, Japanese, Korean, and simplified Chinese. This certification is aimed at individuals with at least 1 year of experience using Amazon SageMaker and other machine learning tools on AWS. If you're a backend software developer, DevOps engineer, data engineer, MLOps engineer, or data scientist, this is for you. Now, the target candidate should have a year of experience using SageMaker and also be familiar with related AWS services. Here's what you should already know before taking the exam. A basic understanding of common ML algorithms and when to use them. Knowledge of data engineering, like how to ingest and transform data for ML pipelines. Experience with CI/CD pipelines and infrastructure as a code. Lastly, familiarity with software engineering best practices for creating clean, reusable code. Now on the AWS side, make sure you also know how to use SageMaker for building and deploying models. Work with AWS Data Services for preparing data for ML models. Deploy applications and infrastructure on AWS. Use monitoring tools for logging and troubleshooting ML systems. Set up automated CI/CD pipelines using AWS services. Lastly, understand AWS security best practices for identity management, encryption, and data protection. Now let's dive into the AWS Certified Solutions Architect Professional exam. Here's what you need to know. This is for professionals with at least 2 years of hands-on experience designing and deploying cloud architecture on AWS. Before you dive into the exam, you should be comfortable with the tools like AWS CLI, AWS APIs, AWS CloudFormation, and the AWS Management Console. Plus, knowing a scripting language and having experience with both Windows and Linux environments is a plus. You should also have the skills to provide best practice guidance on architecture across multiple applications and enterprise projects. Map business goals to architectural needs. Make architectural recommendations for implementing and deploying applications on AWS. Design hybrid architectures using AWS technologies like VPN and AWS Direct Connection. Lastly, set up continuous integration and deployment processes on AWS. We look at the format, question types, and also everything you need to know. You'll have 180 minutes to answer 75 questions, which will be in either multiple choice or multiple response format. The exam costs $300 USD. You can take the exam at a Pearson VUE test center or choose it on online proctored exam. To earn the certification, you need to pass SAP C02 exam. And don't worry, there is an exam guide to help you prep. Now let's dive into the AWS Certified Security Specialty exam. Who should take this exam? This exam is for professionals working on security roles. If you're securing AWS products or services, the certification is for you. I know you will be having the doubt of experience level, right? The ideal candidate should have 3 to 5 years of experience in designing security solutions, with at least 2 years of hands-on experience securing AWS workloads. Before you take this exam, you should have a knowledge of the AWS Shared Responsibility model, security controls on AWS environments, logging and monitoring strategies, vulnerability management and security automation, integrating AWS security services with third-party tools, disaster recovery controls like backup strategies. Lastly, cryptography, key management, and identity access management. Now let's talk about the AWS Certified DevOps Engineer Professional exam and how it can level up your career in cloud engineering. Who should take this exam? This exam is designed for individuals at least having 2 years of experience working with AWS environments. It's for professionals who want to demonstrate their expertise in provisioning, operating, and managing distributed systems on AWS. Before you take the exam, you should be familiar with programming, that is, experience in at least one high-level programming language. Infrastructure automation, building highly automated infrastructures. Next is operating systems, administering different operating systems. DevOps methodologies, understanding modern development and operation processes. Next comes continuous delivery systems, implementing and managing continuous delivery systems on AWS. Security and governance, automating security controls, compliance validation, and governance processes. Last is the monitoring and logging, defining and deploying monitoring, metrics, and also logging systems on AWS. Now let's understand about the exam. You'll have 180 minutes to answer 75 questions in multiple choice and multiple response formats. The exam costs $300. And about location, you can take the exam either at a Pearson VUE test center or online with a proctor. Next, here's the key knowledge you need before taking the exam. 2+ years of experience, provisioning, operating and managing AWS environments. Experience with software development lifecycle and programming or scripting. Automating infrastructure and understanding modern development processes. Lastly, securing AWS infrastructure is also recommended knowledge. The exam consists of 2 types of questions. Multiple choice, where 1 correct answer and 3 distractors. Multiple responses, 2 or more correct answers from a list of 5 or more options. Now let's dive into the AWS Certified Security Specialty exam and see how the certification can set you apart in cloud security. The exam category is a specialty level certification, perfect for those who want to showcase expertise in AWS security solutions. I know you will have a doubt of how exam is like. You'll have 170 minutes to complete 65 questions in both multiple choice and multiple response formats. The exam costs $300. Where can you take this exam? You have 2 options for taking the exam. An in-person test at Pearson VUE testing centers or an online proctored exam. This exam is offered in 6 languages like English, Japanese, Korean, and so on. Now let's see what is the certification about. The AWS Certified Security Specialty validates your skills in creating and implementing secure AWS solutions. It tests your knowledge of data classification and AWS data protection mechanisms, data encryption methods, and how to implement them on AWS. Lastly, secure internet protocols and AWS mechanisms for securing data transfers. Who should take this exam? If you're in a security role, this certification is a great way to validate your skills. The exam is designed for candidates who have a solid understanding of data classifications, encryption, and secure internet protocols. 2 or more years of production deployment experience in AWS security services. Lastly, the ability to make the trade-off decisions regarding costs, security, and deployment complexity. What knowledge should you have? Candidates should have the following experience and understanding of AWS Shared Responsibility model and its practical application. Security controls for AWS environments. Logging and monitoring strategies, vulnerability management and security automation, how to integrate AWS security services with third-party tools, cryptography, key management, and identity access management. Lastly, threat detection and incident response strategies. The exam consists of 2 types of questions. That is multiple choice, where 1 correct answer with 3 distractors. Next, multiple response, 2 or more correct answers from a list of 5 or more options. And remember, unanswered questions are scored as incorrect, so there is no penalty for guessing. Ready to become AWS certified? This certification is a great way to validate your security expertise and gain confidence in your ability to secure AWS solutions. Now, we are diving into the AWS Certified Machine Learning Specialty Certification, designed for anyone serious about ML development in the AWS cloud. What does this credential do? It's designed to help organizations identify and grow talent for critical cloud initiatives. If you are into building, training, tuning, and deploying machine learning models on AWS, the certification can be a game changer. Who is this exam for? This certification is perfect for developers and data scientists with over 2 years of hands-on experience in machine learning or deep learning on AWS. You should also be comfortable with the intuition behind ML algorithms, basic hyperparameter optimization, familiarity with ML and deep learning frameworks, lastly, best practices in model training, deployment, and operations. How do you earn the certification? To earn the certification, you will need to pass the AWS Certified Machine Learning Specialty exam. The test includes 65 questions with a mix of multiple choice and multiple response formats. What about the logistics? You will have 180 minutes to finish the exam. It costs $300 USD and is available at both Pearson VUE testing centers and as an online proctored exam. The exam is offered in 4 languages: English, Japanese, Korean, and simplified Chinese. Now let's see, what knowledge will you be tested on? The exam validates a candidate's ability to select the right ML approach for a business problem, choose the right AWS services to implement ML solutions. Lastly, design and implement scalable, cost-effective, secure ML solutions on AWS. Let's see the ideal candidates. Those who have 2+ years of experience in developing, architecting, and managing ML workloads on AWS are the best fit. Additionally, target candidates should understand basic ML algorithm intuition, hyperparameter tuning, frameworks for ML and deep learning, lastly, best practices for training, deployment, and operations. Next, let's see how are the questions structured. The exam has 2 types of questions: multiple choice, where 1 correct answer with 3 distractors, and then multiple response, 2 or more correct answers out of list of 5 or more. As same for every certification, there is no penalty for guessing. So if you're unsure, go ahead and make an educated guess. Moving forward, let's explore the last certification, that is AWS Certified Advanced Networking Specialty Certification, ideal for those ready to make their networking skills to next level with AWS. Now let's see what is the certification about. This credential is designed to validate expertise in designing and managing network architecture across AWS services, helping companies identify professionals with the right skills for complex cloud networking tasks. We will also see who should consider taking this exam. This certification is aimed at individuals with 5 years of hands-on experience in networking, specifically in architecting and implementing network solutions. Recommended experience includes in-depth knowledge of AWS technologies and security best practices, familiarity with advanced networking architecture like IP VPN, MPLS, and VPLS, experience with automation tools for designing, implementing, and optimizing network architectures, including routing and multi-region setups. Lastly, knowledge of CIDR, subnetting, AWS, WAF, IDS, IPS, DDoS protection, and EDOS mitigation. Now let's see how do you earn the certification. To achieve this, you'll need to pass the AWS Certified Advanced Networking Specialty exam. It consists of 65 questions in both multiple choice and multiple response formats. What's the exam logistics? You'll have 170 minutes to complete the exam, which costs $300 USD. You can take it at a Pearson VUE testing center or through online proctoring. The exam is available in English, Japanese, Korean, and simplified Chinese. Let's see the skills that will be assessed. This certification will validate your ability to design and implement hybrid and cloud-based networking solutions using AWS, operate and maintain network architectures for AWS and hybrid environments, use AWS tools for deploying and automating networking tasks. Lastly, secure AWS networks using native AWS networking tools and services. Now let's see what kind of candidate is the best fit for the certification. Ideally, candidates should have at least 5 years of networking experience and 2+ years in cloud and hybrid networking. Key knowledge areas include AWS networking details and how they integrate with other AWS services, security best practices for AWS. Lastly, understand of AWS compute and storage options. How are the questions structured? You'll encounter multiple choice questions with 1 correct answer and 3 distractors, multiple response questions with 2 or more correct answers among 5 or more options. So, if you're serious about building secure, reliable network architectures on AWS, the AWS Certified Advanced Networking Specialty Certification can be an invaluable credential for your career. So, that wraps up our overview of all the AWS certifications. So, if you've got your certification, you'll have access to great career opportunities. Now let's go to the career opportunities. You could work as a cloud architect, solution architect, DevOps engineer, data engineer, or security specialist. The pay will depend on your experience and where you're based. But these roles offer excellent career growth and good salaries. Let me tell you some exam preparation tips. Once certified, you'll have an amazing career opportunities. But before you go, here are some quick exam preparation tips. First, use AWS free training. Hands-on labs and practice exams are the must. Apply AWS tools. Practice using AWS in real-world scenarios. Next, take practice exams. Familiarize yourself with the exam format. Then, focus on core concepts. Pay attention to key topics like security and costs. Lastly, AWS forums. Get tips from the community. With these tips, you'll be ready to pass the exam and boost your career.
And with this, we have come to an end to this video on AWS fundamentals. If you enjoyed listening to this video, please be kind enough to like it, and you can comment on any of your doubts and queries. We will reply to them at the earliest. And do look up for more videos and playlists and subscribe to the Edureka's YouTube channel to learn more. Thank you for watching and happy learning.